go ahead and introduce you to Swift language. But before we go any further, I'd like to introduce you to the IBM Swift Sandbox, which is in beta, which means they're still working on it. But nonetheless, it's very usable. This is the tool that I want you to use as we proceed into learning more about Swift in this course, okay? I want you to go ahead and type IBM Swift Sandbox. So I'm already there. But for you can just go ahead and say IBM Swift Sandbox, and there you go. Just click on it, and you can just go and click on that one, and this is what you're going to be seeing. Okay, so that's the URL. I'll just get rid of this because you can just get to it using that URL, and I have already opened here. So this is our Swift Sandbox that you're going to be using. In the preceding videos, I will be using a different tool, which is the Playground, which comes with the Xcode IDE, Integrated Development Environment. But fear not, the results you'll get from here using the IBM Swift Sandbox is going to be the same that you would get using the Xcode Playground. You will obviously see differences in next videos in terms of how to compile and run our programs. At the bottom here, this is how we run our programs here. You'll see this execute play button here at the bottom, and once you have some code running there, if you go run, it should show something. And obviously we haven't written any code whatsoever. That's the reason why if you say run, click run, or in many other cases, if you're on Windows or any other operating system, you can say Control S to execute or Command S. The beauty of using this tool is the fact that it doesn't matter if you're on Windows, or Linux, or any other operating system, or even Mac, you don't need to download Xcode so that you can start learning Swift. That is the beauty, and that's the reason why I want you to use this tool here. So Swift is a language created by Apple, the creators of the iPhones and iPads and all of those great devices that we love. And so they created this language so that it would facilitate the development of mobile applications and desktop applications and so forth within the Apple realm of development. Okay, so Swift it's an easier, more intuitive language as opposed to the previous one, which was Objective-C. So Swift language is more compact, a little bit faster, and more robust and easy to learn. All right, enough talking. So let's go ahead and talk about a few things here. Again, as you can see here, we have at the top, the first thing when you open, go to this link, this is what you have. You will see here at the top some comments. So it's a comment because we have 2/ here and here as well. So this is all comment, meaning it's not going to be compiled. And this to the right here is going to be, as you can see, there is this difference in colors here. Okay, so to the right here, this is our console. This is where all of the compiled results will show up here. So at the bottom here, you can have, say, source code. If you click here, you can, they have some source samples. You can just click, let's say, Fibonacci, say start coding, and it shows you all the Fibonacci here. So if you go ahead and click here, you can see it's showing 17711. Okay, you can go back here and find, for instance, Hello World Swift, start coding, and there it is. It shows Hello World, and we can just run it, and we should see in our console Hello World. All right, and then if you want to just clear the code, what you see here, you can just go ahead and click clear, and of course it's going to ask you, are you sure you want to restart over? You can say yes if you wish to do so. And notice it just cleared everything. We have a clean slate. So now let's put a comment here. So //, let's say, let's go and say intro, right? Introduction. Let's go ahead and print something out into our screen, our console here, so we can start seeing the power of Swift. In order to print something out into a console, we just say print, right? Print is a method. It's a function that comes with Swift, and so we have to pass in something inside of that print function. In this case, we can put a string. I know that's a string because I have those quotation marks there. So we can say hello world. Okay, if I go ahead here at the bottom and click run, play, you see here hello world. Okay, Let's go ahead and talk a little bit about variables. And of course, in the next videos, you will see more details what we're talking about. Notice again, variables, this is not going to be compiled when we hit run because it's a comment. So how do you create a variable in Swift? Every language that exists, programming language that is, we have syntax. Syntax, it's just rules we have to follow to be able to create, to be able to actually code. Okay, so here is the syntax or the keyword you have to start when you want to start create a variable. So we say var, okay, that's a keyword, and you say, for instance, my name is equal to Paulo. All right, so what's happening here? We said var, that's the keyword. My name, it could be anything you put here. That's just the name of the variable that we are creating. And this equal here, it's assignment. You are saying that whatever is to the right here, so Paulo, it's going to be inside of my name. So my name now points to Paulo, the string. Okay, just text. So now if we want to print out this Paulo here, we can reference the my name inside of our print. So here, if I go say my name, as you can see, the beauty of this Swift sandbox, it has this autocomplete because it knows exactly we have created this my name local variable here. So it just says, hey, I think this is what you need. So we can just go ahead and say enter and it populates all there. Okay, so now if we go and say and run, we should see Paulo. Beautiful. Okay, so that's the very introduction of Swift. So you understand what's happening here. We created a variable, we assign it to something. In this case, it's a string, and now we can reference this my name and use the print function that comes with Swift. Okay, and then we display Paulo. In the next videos, you'll see me using the playground, which is attached to Xcode, which is a proprietary IDE or tool used to develop application and code in Swift. But don't worry about it. All that you see me do using that tool, which is the playground, you can do here. So the only difference you'll notice is that here you will have to hit execute in order to see the results. All right, so let's go ahead and take a look at other things here. Of course, you can go into seeing about and what's new, and you can give it feedback. But if you go at the bottom here where it says settings, okay, it tells you the selection, it tells you what version of Xcode we're talking about here. So you can click on this drop down menu and have all of these different ones here. I recommend to use the latest, which is March 24th, right? Always try to get the latest here. And you notice also at the bottom, and at the bottom here, select theme. You have a light theme. If you click here, notice it all changed to lighter color, or a dark theme. That's your preference, okay? And we have here enable auto saving, which means it will keep track of what you're doing and save your code. So I just leave it enable auto save, okay? That's all good. And also they have this share code here, so you can actually click on this. You can copy this URL, right? If you want to share this code with your friends or with me, if you have any questions, this is how you do it. You just copy this whole code and send it. Okay, you can just hit copy, or if you wish to share with your friends on Facebook or Twitter, you can do the same thing. Okay, so as you can see, it's a very clean, easy to use tool, a web-based tool, which means anybody can use it. If you are on a Mac or Linux or Windows or whatever other operating system you may have, you are able to learn Swift using this tool. All right, well, thank you very much, and I'll see you in the next video. We are going to dive right into learning Swift. I'll introduce you a new tool called Playground. So once you have your Swift opened, go to File, New, Playground here. Okay, so click on Playground, and this is what's gonna pop out. So what you're gonna do here, let's call this Demo Playground. Okay, and all the rest is fine. Say Next. And we want to make sure we're gonna navigate to our folder. In my case, it's my iOS projects folder. So click Next. And there you have it. This is our playground. Let me adjust our screen here. Now, the first thing you notice here is we have these two forward slashes here. What this means is everything that comes after our forward backslashes, it's going to be comment. A comment essentially is something that the compiler, the interpreter, is not going to read it as code. So this is usually for us, the developers, so that we can write notes for ourselves or for anyone else who will be reading our code. So if you remove this, then you see should have an error. Of course, because it's the compiler is saying, well, I have no idea what this is. So whenever we want to make a comment, we say two forward slashes, and that becomes a comment. Now, if we want to have multi-line comments, meaning if we want to make sure to have a lot of lines that are part of a comment, we say forward slash and we put the asterisk and say enter, and then we close it by starting with the asterisk and then forward slash. And so this means anything we write inside here is a comment. And we can say enter and keep writing. And more, and more, and etc. Right? So it means whatever's inside here is a multi-comment line here, right? So essentially it's the same as what we have here at the top, except here we can say enter and keep writing. We can even write a novel if we want it. All right. Okay, this is good. All right, so let's keep going here. Now the next thing you see is this import UI kit. Now, what we're doing here is we're asking the Xcode to import this library called UI Kit, which has all of the tools, all of the functions, all of the code that we don't have to write. It's already pre-written because this is a language in itself, so we can utilize that. So you can use those libraries in order to then do whatever we need to do below that. So here we're just importing all of the libraries, all of the code, pre-cooked, if you will, code we can use in our programs. All right, and you will, as we go, you will start understanding what this all means. And the next thing you see this line of code here, right? It says var str is equal hello playground. What this means is we are creating a variable. The variable is essentially a little bucket that you put in memory in a computer that says this bucket will be able to hold something for me in my program. So what are we saying here? We're saying, okay, memory, okay, computer, create a bucket, create a little space in memory where I can put a string. This is a string. The reason why we know it's a string because we have quotations here. Everything inside of a quotation is a string. So essentially what we're saying creating a var. So this var here is a keyword that tells the system that you are indeed creating a variable. So you say var variable, okay, the name of the variable equal, you are assigning this str anything that comes after the equal. So you're saying str now contains this. So you are putting whatever you have here, in this case hello playground, into that space in memory, into that little bucket that we created, right? And as you can see, the beauty of using a playground, which is this tool we're using here, again, the playground is not a separate tool from Xcode. As you can see at the top here, still says Xcode. It's just a tool inside of Xcode that allows us to write code and see right away what's happening. Instead of going through the process of compilation, compiling, and doing all the work, it just straight away spits out what we are writing. As you can see to the right, we have here says hello playground. Okay, so that's wonderful. That's the beauty of using Playground, especially for the purposes of learning this new language, Swift. All right, excellent. So what we can do now, let's go ahead and create something else. Let's go ahead and say var my name, and we assign it to, so we say equal, and we open our string here. So this is we open the quotation and we close it. it already knows that you are about to write a string, so it just completes that out for you. All right, so we can say here Bob. Okay, obviously that's not my name, but you get the idea here. Okay, so there it is. There's our Bob, and right away we can see here. So this is a string. Now we can do other things too. Now we can print out, which means we want to show whatever we have stored in our my name here. So what we can do, we can use a method, which we will talk more later about. But one of the main methods we can use right away is print. As you can see, it's a method, so it's a function which takes in whatever we want to print inside. So when you say here print, say enter, and then inside we can pass in either a string, direct string, or we can just pass in a variable, in this case my name, say enter, and we should see Bob. So that's what a variable is. Just think of a variable as a little bucket that you can put things inside of it, right? Now, this variable we talked about here is a variable of type string. The reason why is we know it's a string because it's holding a string here. Hello playground, Bob. These are strings. They're just text. The other way we could have expressed our str variable to be a string, we could have said something like this. Put colon and say string. As you can see here, get that string. Here, what we're saying, we are explicitly, we literally are telling the system that this str variable here is of type string, meaning you cannot put anything else into this bucket here, str, other than a string. So we are explicitly telling the compiler as well as the people, anyone else reading this, that this is a string, right? You notice that nothing really has changed here. It's still saying hello playground. If we get rid of this, it still says the same. So it's up to you if you actually want to put this string here to tell the compiler and yourself that this str is of type string, okay? As you can see, again, nothing really has changed. Now, the other important thing to consider here is that you'll see here we said print and we passed in my name, which is this variable here. We could have very well just said Bob, and that would have worked too, right? But we instead first put Bob into a variable, into that little bucket in a memory, so that we can then use it as opposed to write Bob again. And you will see why this is much better programming than just putting straight Bob here, right? Put things into buckets, because then we can use that bucket and do all sort of things before we want to display whatever we want to display. And you will see more of that. In this video, we were able to look at a string and how to create a string and how to explicitly or implicitly create a variable string. Here, as you can see, we can put a string, say string is of a type of a string, you know, the str variable is of a type of a string here, or we can just say, go right away and say var name is equal to Bob. Obviously, the system will know if you have declared Bob, that means this my name obviously is a string. So you don't necessarily have to have this string here, okay? I would like you to do something. Go ahead and create other variables and print them out so that you get used to creating variables and print them out, okay? So just go wild, just go play with it and learn a little bit more about it, okay? In the next video, we will continue talking about variables and variable types. All right, see you in the next video. Strings, and now we're going to introduce another type of variable called integer. So an integer essentially is a number. So previously you learned how to create variables, right? So you start by saying var and then name of the variable and then equals whatever you want it to be. In this case, a string, then you put a string, right? Just as we have it here. All right, and of course you can put the type, as you can see here. This is how you read it. You would read saying string or str is of type string. So we know this. Let's put a comment here again. // that's a comment. We know this is a string. Now what if we want to create then an integer? Okay, what we do, Well, we will do the same thing here. We will say var, let's call this my int, is equal to, say, 4. And as you can see here, it says 4 right away, okay? And we can go ahead and print it. We can say my int, and there we go. Of course, the same thing. You can see it's going to print it, 4, okay? That's great. We can obviously also explicitly say is of type, so my var, so my int variable is of type, start typing int, and we can just get that integer there. You see it's the same thing, nothing really has changed. Okay, what if we wanted to print a string along with a number? What if we wanted something to say I have 4 oranges, but knowing that this 4 is actually an integer? Well, what we can do, we can go ahead and say print, because that's our print method, right? And inside here we can say I have, and then if we want to use these integers, here it is my int number 4, because it's type of integer, it's not a string, so we can't just go ahead and say my int and see if that works, right? It's not going to work. So what do we do to concatenate, or to kind of glue together two different types of variables, in this case a string and an integer or number? What we do, we go backslash and then open parenthesis and close, and then inside here, that's when we can actually go ahead and say my int. Now you notice we have I have backslash and then open parenthesis, and then we put our variable, in this case my int, because it's an integer and has 4. So you see here it says I have 4. And then we can proceed here to say oranges, or whatever we want to put there, or mangoes, right? So I have 4 mangoes, I have 4 oranges, right? Whatever we want to put here. So as you can see, we have now inserted 2 different types inside of the print method here, and it's showing here I have 4 mangoes. Instead of putting a variable here, we can go ahead and put a number here, 5. Guess what? It's going to work, right? But since we have a variable already here, we're going to put it here inside my int. All right, great. Now, the other thing we need to talk about, as you noticed, we've said here to create a variable, we said var, because that's the keyword we need, and say we have the name of the variable, so we can put whatever we want here. We could either explicitly say what type, in this case we say colon and then the type, right? Or we can get rid of it, doesn't matter, still works. This is how you create a variable, and in this case you are assigning a variable to something, right? Hello playground. There's another way of creating a different kind of variable. This different kind of variable is not a type, so this, when you say var string, you're creating a variable. But there are times when you want to also create a say a constant variable. So a constant variable, it is what it is. It's exactly what the name implies. A constant variable is not supposed to change. Here's an example. As we say here, var str is equal to hello playground, right? Let me go back here. Let me comment this code out. So /, this is now a comment, which means it's not going to be shown here, right? As you can see, it's gone. So let's go try something really interesting here. We said var string or var str hello playground. I'm going to show you that this is actually a variable that changes, right? You can change this str to whatever you want down the road. You can go ahead and say str again is equal to I am different. Okay, and you see now if I go here and say print and print this str again, so let's copy this here, guess what's going to happen? I am different. Well, but you would say, but you said str here, you put in that bucket hello playground, right? So whenever you create a variable that you want to be able to change at a later time, as you write your code down here, you can certainly use var string and then initiate it, right? As we did here. And then you can change as many times as you want. And if we can go ahead here and say str is equal I have changed again. You notice here, we're still printing. Now it's saying I've changed again. It's not saying I'm different, the new one, right? So we can keep doing this. There are times when you want a variable to be unchangeable, right? That's when we use a different keyword as opposed to var. What we do, I'm going to get rid of this and all of this because I don't want to complicate things here. What we do now is the following. In fact, I'm not going to get rid of anything. So I'm going to go ahead and comment all of this out. The way, if you want to comment more than one line, just highlight everything and go command and / and look at that. Everything is highlighted now. Okay, good. So I'm going to put it down there so we don't get distracted. Okay, now in order to create a constant variable, you wouldn't say var. Now you said let. When you write this keyword let, my var, my constant I will call, is equal hello, I am hello constant. Okay, of course, if you look to the right here, right, it says hello constant because it's still, we know it is, of course, a string, right? But now check this out. If I go here and say print and I say my constant, say enter here, it's gonna say hello my constant. Now let's try something very interesting here. Let's go say my constant is equal to I have changed. What's happened? Why isn't I have changed showing here? Still saying hello constant, but I just said here my constant is equal I have changed. Aha, there is the thing. That's because we said let my constant variable is now a constant, which means you can't change it. The system won't let you change it. Right now you may not see the purpose or the reason why you would want this to happen, but later you will see, as we build our applications, you will see, oh, I see why the difference now, or why or when should we use let versus just a standard variable. Let's say you have a constant, let's say the pi number 3.14. That's a constant number. You don't want that to ever be changed in your program, right? So that the pi number would be a number that you don't want it to change throughout your program, because that would create a lot of damage. I'm sure you now can see the usability of having, or the usability of constant variables as opposed to just standard variables. All right. Okay, good job. So I will see you then in the next video, where we will keep going and learning more about this beautiful and easy to learn language that is Swift. I'll see you next. About Swift and what makes up Swift. So we have been talking about variables and strings as well as integers. So previously I showed you about constants, how constant variables are different from normal variables. So you can see here, you can say let a constant. To make this my constant variable a constant, you have to start with, you have to use the let keyword. If you just want to have a normal variable, which can be changed along the way in your code, anywhere else, you can just say var. Okay. We also learned that, let's say if you want to print out something like this, I have 5 oranges, but I want to use, for instance, my int variable here. What we do, we set / open parentheses, let's close them, and then inside here we just go and say my int, and then after that we just continue with our string. I have in this case is going to be 4. I'm going to say mangoes. This is how we put together, we show variables inside of our strings, inside of strings. Okay, so as you can see here, it says I have 4 mangoes. But we can also, if we wanted, let's say if we had another string here, I'm going to go ahead and comment this out. And just to give more space, let me comment out everything else here so that we don't have to worry too much about this. Let's go ahead and comment this out. And I'm going to go ahead and put all of this below here so we don't see it. All right, let's say, okay, so now all we have is this hello playground, which is this string here. Let's say we had another string here. Let's say var my other other string is equal to hello, this is great. All right, so now we have this hello playground, and then we have this is great. So what if we wanted to print out these two strings here? So hello playground and this is great. How can we do that? Well, what we can do, we can also, since these are of the same type, so we have a string here and this is also a string. To do so, what we do, we just say print, right? And then we say str, and we say plus and my other string. Now this plus here is not the mathematical sense of adding, right? So here, since we know both of them are strings, what's going to happen? The first string here, hello playground, will be concatenated, or we will glue together. We want them to be kind of side by side as one word, as one sentence, as one string. So what we're doing here, we're just saying string, which is going to be hello playground, and my other string here, which is this is great. We are putting them together to show all of them in one line, which you can see here says hello playground, this is great. Now you notice that we have another issue here. So it says hello playground, and then there's no space at all here, and it says this is great. The reason why is because, as you can see, our compiler doesn't see space, or doesn't just include space when we are starting a string. Meaning that if we want to see that space here in between playground and this word here, we could either go ahead here and go like that, because now we gave a space here. As you can see right away, we have playground, this is great space. And we should see right away it says hello playground, this is great. So we have that space there and all is good. So we can go ahead and create a few more here if we wanted to. So we can say more string is equal to hello again, this is new, right? And we can go back here again and say plus, we use that variable here, more string. Right away you can see now we have all these three variables here which contain all the strings. We should see it showing here pretty soon here. When it decides to show, it should show everything here. Let's see what's going on. And as you see, there it is. We can just click this kind of quick look eye thing here. Just click on it, and then you will see hello playground is great, hello again, this is new. Of course, if you wanted to put that space in there, we'll just go ahead back here and give that space, and all should be good. All right, so what I want you to do, I want you to go ahead and exercise and do this. So create a variable, in this case it's just a normal variable strings, and start putting text as we did here. It's just a string, hello playground. Doesn't have to make sense. As you can see, this is not necessarily a sentence that makes sense, but it's just a way for you to practice and start seeing how to concatenate, how to glue together different pieces of strings and put them into one. All right, so great. So go ahead and do that, see if you can manage that, and I'll see you in next video where we are going to start talking about the arithmetic operators, so we can start adding, subtracting, multiplying numbers, etc. All right, so I'll see you in the next video. Forward, and we're going to talk about arithmetic operators. The first one we're going to talk about is going to be addition. So we will learn how to add two numbers, and then we'll move on and talk about subtraction. So how to subtract two numbers. Learn how to multiply numbers, how to divide numbers, and we will then introduce the remainder operator. If the remainder concept is a little bit new to you, don't worry, you will see in action when I show you how to use it. Let's get to it. So as you know, so addition, subtraction, multiplication, and division, those are the most basic arithmetic operators. Okay, so if you have, I'm hoping, go ahead. If you don't have, so now is the time to open our Xcode. I already have mine here. As you can see at the top, it says Xcode. So go ahead and open yours. You should know how to do that by now. All right, and so what we're going to do, we're going to say File, New. Again, remember we are still working with our playground, so we're going to create a new playground project. So say playground project, we're going to call this arithmetic operators. All right, say next, and should now create our playground. And there it is. That's perfect. Let me make sure this is kind of, let me utilize this space we have here. Okay, that's perfect. So as you see, again, we have our new playground project. Nothing new. Now you pretty much know exactly what's happening here. So the first thing we need to do, we are going to talk about, so I'm going to go ahead and get rid of this string here. So I'm going to create a comment. The first thing we're going to look at is addition, which the symbol, as you may already know, is just the plus sign. Okay. So how do we add numbers? So the first thing we need to create is to create two integers. Okay. So as a small challenge here, I want you to go ahead and create two variables, not constant, but two variables with integers. All right, give it a try. Okay, so I'm sure you managed it. So what I wanted you to do is essentially say var, say instance first number or first num is equal to 5, and then var second num is 10. Now that we have that, in order to add those two numbers, what we can do, we can just say first num plus second num. And as you can see right away here, it says 15. Why? Because, well, 5 plus 10 is equal to 15. The other thing we could do, since you know a lot about variables now, we can actually go ahead and create a variable which will hold the sum of these numbers, right? So we can say var sum is equal to that, and then we can actually print it using our print method and say, we can go ahead and use a string to say the result, because we know about strings now. So we can say the sum of, we can then use the first variable and second variable. As you know, first number and second number are integers, which means the sum is an integer. If we want to refer these variables inside of our string here, we'll have to do backslash, open parentheses, and close, and say the sum of first num, right, and second, and we do the same here. Second num is, we'll do the same like here. We want to glue all of this together. It's going to be equal to sum. And now everything is looking really, oh, I said sum, whatever that is. Sum. There, the sum of first number and second number is sum. So as you can see here, we were able to print out our string, and inside of the string, we have the actual numbers that we're using to add. So now it's all showing beautifully here. So we've used the skills that we've learned in previous video and put everything together. Now the second operator we are going to learn, it's going to be subtraction. Say here, subtraction. All right, so what we can do now, let's just go ahead and change these numbers here, say 10, and this one say 8. To subtract two numbers, of course, the sign, the symbol we use is this dash here, minus, okay? All we have to do here is just go here and say minus, and what you have here says the sum, well, actually it's not sum, we have to say the result. We can say the result of first number minus second number is 8, is 2, I mean, all right? So the result of 10 minus 8 is 2, which is absolutely true. That's great. So we have learned how to do subtraction. Now, the next one is going to be multiplication. So let's see multiplication here. Now, for multiplication, the sign, what we use is actually an asterisk. So it's like you say shift and hit the number 8 key, and that's what you're going to get, asterisk there. So what we need to do, we just have to come here and change this, and you will see the result of, and so you can say times. You should see it right away. It says 10. The result of 10 times 8 is 80. That's wonderful. So as you can see, nothing really complicated here. Okay, so going back, we created first num, which is an integer because we have set it to be an integer here, is 10. And we say var second num is 8. And then we create a variable that will hold the sum, or, well, in this case, actually, as we've changed, let's just say result, so that we are actually instead of sum, I'm going to say result because we've been changing using different operators here. So let's just change this to result to be more appropriate, I guess. So let's go paste here. Okay, so, and then we have this variable called result, which will hold whatever operations we are making with those two numbers here. Okay, and then we're printing everything out using our print method, which comes with UIKit, which comes with our playground, which comes with our Xcode from libraries. And then inside there is a string, but we're also concatenating. So putting inside of our string here, we are putting our variables which contain numbers and result. That's all we're doing. All right, great. The next one we're going to learn how to do is the division, which we use the / for our division operation. What do we do here? We can just go ahead here and say divide divided by second is 1. Well, 10 divided by 8 is 1. It really isn't 1, right? Because if we go ahead, let's see, let me see, let's go, I'm going to go ahead and open a calculator here. So we are all on the same page. So let's see here. I have my calculator, my fancy calculator here, okay? So if I say 10 and divide it by 8, it's not 1, it's 1.25. Now, why are we getting 1 here? You may ask. Well, it turns out when we create here this 10 and 8, those are whole numbers, okay? If you divide two whole numbers, that will result in a non-whole number, so like a number with decimal points, then what's going to happen, Xcode will say, well, these are whole numbers, therefore the result has to be a whole number. In that case, since the result 10 divided by 8 is going to be 1.25, it's going to just go ahead and round it to 1, because it's going to say, well, because both of these numbers here, they're all whole numbers, right? They're not decimal numbers. Therefore, the result has to be a whole number as well. There is a different kind of number called double. A double allows us, let me write here. A double is a type, allows us to make things a little bit precise, meaning that in this case, if we were to use doubles, we will actually get the right value when we divide 10 by 8. Because obviously, you know, as I've shown you here, 10 divided by 8, it's not just 1, it's 1.25. So we have a few options here. The first option would be, well, we know that when we say var first number is equal, first num here at the top is equal to 10, because we just put 10 here, we are initializing this variable first number. We said 10 and it's a whole number. This assumes you were talking about an integer. Now, previously, remember, if you remember what we talked about previously, that this is implicitly, we are initializing our first number to be an integer, because we're just saying, well, is equal to 10. Now, if we could have said this int, so we are literally telling the system and ourselves too, that this first number here is of type of int. This is what it means here, the colon, right? We're saying first number is of type int. That's what we're reading here, okay? Now, in order for this to work, to make so that we actually have it a double, that way we have the correct function, the correct number result here that we need, what we can do, we can say double, because now we are changing this first number. We're saying first number is of type double. And we have to do the same with our second number. So say double here, say enter, and these two are now doubles. And you notice right away, our result here, it says 1.25. Because now these two first numbers, first num and second numbers, are doubled. Therefore, we get the right result. whenever you know that the result needs to be precise, let's say if you're running an app that converts temperature or deals with pricing, let's say it deals with prices of certain items, right? Unless you know exactly that, okay, the price or the temperature is going to be 10 or 20 or a whole number all the time, then you should always use a double in this case, because then you get the actual correct number with the decimal points needed. All right? You see the difference here? Just because we said integers, set everything to integers, we got a wrong number. Because 10 divided by 8 as an int, if those two are integers, it's not 1. And so you will see this case many, many times in the future here. So if this doesn't make a lot of sense right now, don't worry, you will get it, because we will have other opportunities to talk about this, okay? Good. So we did division, it's working, and now we need to go ahead and do now we're going to go ahead and learn about the final one called remainder. For remainder, we use the percentage sign. So a remainder is what remains, right? So if you think, let's say if we have, let's change this back to int, right? And int here. Let's change this to 9 and change this to, say, 4. And here, say, let's copy this. Say this, and let's go ahead and comment this out here. I'm going to put this at the bottom here so we don't get distracted. And here, oops, int. Okay. All right, so we know for sure these are integers. So now let's go ahead and change to remainder here with percentage sign. So you go shift 5, and there it is. This is our remainder. The remainder from, let's see, the remainder from, let's put ampersand here, a percentage sign. The remainder of first ampersand, percentage sign second is 1. You may ask, what is this remainder thing then? This is what's happening. I have a little diagram of what the remainder is here. So if you look here, if you say, as we said here, 9 remainder 4, so 9 ampersand 9 percentage sign 4, this is what's happening here. What we're saying here is, let's work out how many 4s will fit inside 9. So you look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 little boxes here. So we are saying, okay, if you say 9 remainder 4, you're saying, okay, how many 4s will fit into this 9 spot? In other words, we're saying, okay, we have 9 chairs. How many group of 4 people will fit into 9 chairs to where all of them will be seated? Well, in that case, we know that 2 4s will fit into 9. And the rest, it's going to be 1, which means you can fit 2 4s into 9 and you will have 1 remaining, right? Because 4 plus 4, that's 8, and we only have 9 seats, which means we have 1 left. That's what a remainder is. So that's why you are getting here a 1. So 9 remainder 4 is 1. What if we go ahead and say here 10? With the same concept, well, how many 4s will fit into 10? Yes, you guessed it. If you said 2 4s still, but the remainder is going to be 2, because 4 times 2, so 4 4, or 4 plus 4 is 8, and we still have 10. That means 10 minus 8 is 2. So the remainder is going to be 2. That's all what a remainder is. And this may not make sense, and you may ask yourself, so, well, okay, remainder, when am I ever going to use this? Well, there are many situations where you'll be able to use the remainder operator. It may not seem very obvious right now because we're just still learning the language, but at a later time, you will definitely see an example where we use a remainder operator. All right. Okay. So I encourage you to go ahead and play around what we've just learned here, right? So we learned about addition, how to add 2 numbers. We'll learn how to subtract, multiply, divide, and we'll also learn about doubles. And we just learned about remainder operator. Wonderful. So go ahead and play around with this concept here so you can see all of it in action. It's pretty fun. I always enjoy doing this because it's really fun to see bits, to see how things work as we learn how to program in Swift. And I'll see you in the next video. So now we're going to jump into the comparison operators, which are very important in any programming language. Because again, if you think about programming, you think about decision making. That's what a program essentially is. You're deciding, okay, what code to run, at what time, and when to run, right? So with that said, we obviously need to learn about some basic, frankly speaking, the main comparison operators here. The comparison operators we're going to be looking at are the following. Equal to. Now notice here we have double equal sign. We'll be able to distinguish the difference between this equal to the assignment equals, which we've been using to assign things to variables. The next one we're going to look at is not equal to. Notice there's the exclamation point or exclamation mark and the equal sign, right? So that means not equal to. We have greater than. We have less than, we have greater than or equal to, we have less than or equal to. All right, so these are the main comparison operators we are going to be learning about in this video. All right, so let's jump into Playground and start coding. All right, so we have this Playground open here from previous, so we're going to go ahead and create a new one. So say File up here, New, we want to say Playground. So we're going to create here, we're going to name this comparison operators. Okay, so iOS is totally fine. Say next. And of course, we're going to go ahead, you need to go and find where you are going to be saving this. So for me, I'm going to go ahead and save it under my iOS project. So here, that's fine. Create. And there we go. We have our new project, Playground project. All right, let me go ahead and make this a little bit, expand this here a little bit. So we can use all this space. All right, so great. So we're gonna go ahead and get rid of this. So we start fresh. I'm gonna start putting comments here. So the first thing we're gonna learn is the equal to sign, which is gonna be this double equal sign here. All right, so let's go ahead and create a few variables here, a couple of variables. So the first one, I'm going to say var. I'm going to say a is equal to 1. And the second one is going to b is equal to 4. Now, in order for us to compare these two variables and see whether or not they are equal, simply we can go and say a is double equal to b. Now, notice something what's going to happen. It's going to say false. And we'll talk more about Boolean later, okay? But what's happening here is that as we compare A, and we know A is 1, and we have B variable is 4, what are we doing here? We're saying A is equal to B. Well, it's false because A is not equal to B. As you see here, A is 1 and B is 4. Therefore, we get a false. And we'll see the full implementation of decision making in our code once we learn about if statements and so forth. So these double equal signs here is comparing whatever we have to the left with what we have in the right to the right. Okay, so we're saying A is equal to B. Of course, Playground here went ahead and say it's false because it's not true, right? Because A is not equal to B. 1 is not equal to 4. Right? If we were to put here 1, you will see this should be true, which is true. A is equal to B. So 1 is equal to 1. Okay, so that was our equal to comparison operator here. The next one we're going to look at is not equal to, which we use the exclamation mark and an equal. In programming languages, whenever you see an exclamation mark preceding anything, just think of it as saying not. So essentially, whenever you see exclamation point equal, that means not equal. That's exactly what we wrote here, right? The exclamation mark in programming just negate or makes it the opposite of what it is, if that makes any sense. So let's give it a try. Let's change this to 3 again, or to a different number. And instead of equal here, let's put the exclamation mark. Let's see what's going to happen. So we know that A is 1 and B is 3. So we're saying A is not equal to B. True. Right? Because 1 is not equal to 3. Had we said 1, A is equal to 1, I mean A is equal to B because both of them are 1, so this should be false. And indeed, if you look to the right here, it says false. Great. The next one we're going to look at, it's going to be greater than. So it's going to be, so this is greater than. So essentially you go shift and you hit the comma key to get the greater than. All right. So in this case here, let's test this out. Let's say A is greater than B. Is that true? Is A greater than B? No, it's not true, therefore it's false. And the next one you may have guessed is going to be less than. All right, so we can go back here, put less than. Again, it's just shift and so hit shift key simultaneously and hit the comma key. This is what we get. So A is less than B. Let's see, is that true? It is true. Why? Because A is 1, B is 3. Therefore, this statement here, it's going to be true. All right, so we're moving along pretty nicely here. All right, so the next step will be greater than or equal to. So that's the sign, that's the symbol there. So both symbol we have greater than and equal to. So let's go ahead and try it out here. So we can say greater than or equal to. So A is greater than or equal to B. Is that true? No, it's false because A is 1, which means it's not greater, nor is it equal to B, which is 3. All right. Getting the hang of it. Okay, so we're getting there. So let's go ahead and get this one less than or equal to. So you may have guessed already. Of course, we go less than, equal to. Let's go ahead and do the same here. Say less than, equal to. Let's see if this is true. So A is less than or equal to B. Let's see, is that true? Says it's true. Let's verify. So A is 1, which means 1 is less than 3. That's great. And indeed, A is less than or equal to B, right? Because 1 and 3. You have learned the comparison operators, which I tell you now, this is the basis of all computing, of all programming, if you think about it in a very raw, in a very essential way. Because if you think about it, once we go a little bit further into programming and start learning other things, you will realize essentially it's all about decision making, right? Because you will find situations where you could say, well, if this variable is greater than this number here, then I want this to display on the screen. Guess what operator you are going to be using? These operators here. This one here should be, there we go, parentheses. I'm sorry, I just saw that. Okay. Again, as usual, I always invite you to go ahead and play around with these comparison operators on your own, so that way you get more and more familiar with it. All right, okay, so I'll see you in the next video. That's called logical operators. So go ahead and create your own project and name it logical operators. By now, you are a pro at doing this, so I'll let you do that. So, all right, so the first thing we're going to look at, it's going to be the not. So it's going to be the logical not. The logical not is an exclamation point, as you can see up here. Now let's go ahead and create two variables here. Let's say var A is equal to 1 and var B is equal to 4. Now these logical operators I'm going to be showing you will make much more sense once we start learning about if statements. So for now, we're just going to learn about them and how to use them. And then later, once I show you about if statements, then we're going to start putting this knowledge we're getting here into practice. Okay, so let's do something here. Let's say we want to compare A and B. Now, in order for us to compare A and B, we would say A, we put double equals B. Remember, this double equal here is very important because we're not assigning B to A, right? So double equal means we are comparing A to B. And you look to the right here in our console, it says false. The reason why it's saying false is because indeed, if you look at A is 1 and B is 4, those are not the same. Now, you may also say, why is this saying false here? What is this? Now, there's another type of variable called Boolean. A Boolean essentially returns false or true. Just think of a Boolean as a variable that can hold false or true, off or on, 0 or 1. Those are the two states Booleans hold. So in this comparison here is returning a Boolean, which is indeed false or true. In this case is false because 1 is not equal to 4. Now, in order to negate, in order to use the not logical operator here, we go ahead and get rid of the first equal and put in exclamation marks. So it's going to be shift and hit the 1 key. You get this. So now what are we saying here? We are saying A not equal, because as we say logical not, so the exclamation point negates whatever comes after. So now here we're saying A not equal to B. Well, that is true, and it says true because A is not equal to B. A is 1, B is 4. Great. Now let's go ahead and look at the next logical operator here. It's going to be AND. And for AND, we use 2 ampersands. So the ampersands, you go shift and hit the 7 key twice. There we go. We have our AND. Now let's go ahead and change this into actual Boolean. Let's go and say A equals to true. And we're going to change B to be false. All right, so let's go ahead, put this at the bottom here so we have more space. Now let's go ahead and say something. Let's go ahead and say A and say shift 7, so 2 ampersands, and B. Let's see what we are going to get here. So if you look to the right here in our console, it says false. It turns out that AND, if one of the variables that we're comparing is false, then everything is false. That's why we're getting false here, because as you can see here, A is true, B is false. If we say A and B, the result is going to be false. Go ahead and say AND is always false if one variable is false. And again, this will make a lot more sense the later time when we start putting all of this into action. Now, the next one we're going to go and take a look, it's going to be the OR. OR sign is going to be shift and go ahead and hit the backslash key twice, and we have those 2 pipes there. That's going to be our OR. Okay, now let's go ahead here, put this at the bottom. Now let's go ahead and say A or B. What's going to happen here? Oh, look at that. You probably have noticed something very interesting here, because if we said AND, we know that if only one is false, then the result is going to be false. Doesn't matter if the other variable is true or false, it's always going to be false. Turns out that OR is different from AND, of course, in that is the opposite, right? Because now if you look to the right, the result is true, even though we have one false. So with OR, we can infer that is always true if one is true. All right. Well, ladies and gentlemen, I have to tell you now, you've just learned one of the basics concepts in computer science. All right. So again, if this is not making a lot of sense right now, I promise you it will make a lot of sense later. But you just understand here, we have logical, not, and OR. So these are the basics ones, logical operators we are going to use many times in our programming career. All right. All right. So good job. Go ahead and play around with this concept again, and I'll see you in the next videos. Structure variables and how to use certain tools that already come with Swift. First data structure we're going to look at is arrays. So think of an array as a table such as this one here. So think of an array as a table where we can put data, we can put strings, we can put numbers, but this data is organized by index. As you can see here, our index starts with 0. In programming languages, indexes usually starts at 0. Okay, so index 0 in this case, we have value mangoes. Index 1, we have cows. Index 2, we have oranges. 3, lemons. So that's how an array is structured internally. Well, let's go ahead and take a look in code and how to create our arrays. All right, let's get to it. All right, great. So let's get rid of this here. We don't need that. So arrays. So let's put a comment here, array. All right, so how do we create arrays? Well, simply we can say var. I'm going to name it my array. And this, then I'm going to set it to say equals to, so open square brackets here and close. So this here, this, when we put square brackets, this is how we can tell we are talking about an array. Okay, so these square brackets here, inside this square brackets, that's where we are going to put our elements, our values. In this case, we can go ahead and put numbers, so say 12. And all of them are separated by comma. So 12, we can put 11, 56, and 10. All right. So as you can see here, we have all of those values inside of our array. Now you notice this array, you could guess that this array holds integers. Also, we could have done this. We could have said my array and then colon. We'll then go ahead and open square brackets and close, and inside here we put the type of values we want this array to hold. In this case, if we wanted to say integer, so we would have said int, right? And then we would have said equal, and then we would go ahead and say 1, 5, 6, etc., just like that. So let's go ahead and comment this out here to see if this actually works. And as you can see, this works. All right, so these are two different ways in which we can initialize our arrays. So this is very explicit. We are saying here my array is of type, so that's what this colon means, integers. And notice it's the int is inside of square brackets, because that's what tells the system that we are talking about arrays. And of course, we then assign this to all of these values. All right, so that's another way of initializing arrays. Perfect. So now we have this array of integers here. Now let's go ahead and say print, and let's print my array. Let's see what's going to happen. And there it is. As you can see, it's printing my array. So when I introduced arrays, I said that all values inside of an array can be accessed via index, because as you can see here, this is spot 1, index 0, right? Because all of the indexes start at 0, not at 1. So this will be spot 0, spot 1, spot 2, spot 3. Okay? Now, the length of an array is essentially how many spots this array has. In this case, it has 4. We can find out the length of an array, or the count of an array, how many items inside of that array, by saying my array and then say dot count. Just like that. And you see here it says 4. What this means here is that we are saying my array, so this is the variable which is holding this array here. We say dot, which means access the count attribute. So it's telling us what is the count, what is the length of this array, which is 4. Okay, because we have 1, 2, 3, 4. Not to be confused with index. Index here will be 0, 1, 2, 3. Index and count are two different things. Okay, the count is just the length of the array. It's just how many items are inside of our array. When you count the indexes, you always start at 0. So 0, 1, 2, 3. Okay, so this is how we print the count. Let's say if we wanted to retrieve number 11. What would we do? Well, in order to get number 11, let me comment this out here. To get number 11 in our array here, we'll say print, and we'll say my array, because we are accessing, this is the array here. We'll go ahead and put square brackets here, square bracket, and then inside here, we would put the index number. So we know that 11 is the second here. So we know also that we always start at 0. So it would be 0 and 1. So if you put here 1, then we should get 11. And there it is, 11 indeed. Knowing about the index is very important because you can see, you can easily make a lot of mistakes thinking that, okay, if I want number 11 here, that means I'm going to go and find 2. index 2. That would be wrong because 2 would give us 56. Why? Because everything starts at 0 when it comes to index. All right, so that's a very important thing to always remember because that can cause a lot of headaches down the road. Okay, so just to remember, arrays always start at 0, index 0. So the first item is always 0 index, the second one is 1, and so forth. So another challenge, what if I wanted the fourth item here from our array? What number would I put here? All right, if you say 3, you are absolutely right. So there we go, 3, 10, and which is the fourth number here. Perfect, great. Now, similarly, as we here, this is this integers, right? We could also create my string array. All right. In this case, we're gonna put there our square brackets and close them, and inside here we're gonna start putting strings. We can say apple and then comma, and another item would be mango, comma, let's say grapes. Okay, as you can see here, all is there. Let's print that out. Let's go here and say print, and we're gonna print my string array, and there it is. Just hit enter, and there we go, apple, mango, grapes. Same thing here. If we wanted to know what's the length or what's the count of our array, we're gonna go ahead and say print and say my string dot count. Okay, and it says there 3. Now if we wanted to say create a string here that says, let's say my array count is, as you know now, you can go ahead and say backslash, open parenthesis, and like that. And now we should get my array count is 3. Notice, remember, this notation is very important because this is a string here, and we want to access this variable, which is my string array here at the top. All right, so we got the count. The same way we were able to fetch a certain index value here, we can do the same with our string. Nothing is different here. So we can say, for instance, if I want my string, I want to get grapes, I would say my string, and of course I'm going to have here the square brackets because I want to access a certain index. If I want grapes, that would be 2, right? It should say here grapes to the right. We can also append, which means we can also add items into our array. So for instance, let's keep going with our my string array here. We can say here append, or just add to existing array. Now to do that, we simply say, again, we're going to go ahead and say my string array dot append. As you can see, there is that method there, that function. So say append, just click enter. And inside here, we can just add whatever we want to add to this list here, to this array, right? Let's say we want to add bread. You notice right away, apple, mango, grapes, bread. So bread is now added into our my string array. And we can see that by, if we wanted to verify that, we can say print, and say my string array again. And we should see here it says apple, mango, grapes, and bread. Obviously, we can do the same with the my array number here. We can go ahead and say my array dot append, and we can say 7, for instance. And right away, you'll see here it says 12, 11, 56 here to the right, 10, 7. So we added another one here. And we can go ahead and say print. If we want to see what's the count now, we can say my array dot count. It should give us 5. All right, because now after adding 7, we'll have 1, 12, 2, 3, 4, and the 7, which is 5. So as you can see, there's a lot of things we can do with arrays because one, we have index for each value that we put in our array. There's another way to add an item into our array, which is a little bit strange in syntax, but what you can do also, you can say, for instance, my string, we could go ahead and say plus equal, and then we go ahead and say, put our square brackets there and say hello. Sorry, it's a string, say hello. There we go. So it says 5 elements, so we really can't see. Let's go ahead, make this a little bit bigger so we can actually see everything. As you can see here to the right, I say apple, mango, grapes, bread, hello. So this is another way of adding an item to an array. So the syntax here which can be a little bit strange to the eye is we added a plus equal. We'll see this syntax as we progress in our course, but this is essentially saying we are adding this item into our myString array. Now notice the difference here. When we use append, we're just passing in right away a string, whatever we want to append, depending on what kind of array we are talking about, right? But here it's a little bit different. We're actually having this square brackets here, which signifies we're actually putting the entire array inside of our string array, myString array here, this variable. This is just another way we can add something to our arrays. Obviously, we could have done the same to our int array. So we can go ahead and say my array, there, or that one there. We can say plus equal, open square brackets, close that, and then just put, say, 67. And we can see here we have 12, 11, 56, 10, 67. Right? Because we are adding to our my array here. Now, what if we wanted to add, say, give space here, and add item to a certain index? What if we want to say, for instance, here in my string array variable here, array, what if we wanted to change, add, instead of having apple, which is the first index, is index 0, if we wanted to put something else there? Well, it turns out there's a way we can do this. So we say myString dot, and we say insert. As you can see there is a method that comes with an array, which we can do things with it. So in this case, we want to insert. And the first thing we have to pass inside of our insert method here, and again, don't worry, we will talk more about methods at a later time. The first thing we need to pass here is the value we want to put in that position. Meaning, in this case, if we want to put, let's say, new value. Okay, so this is the value we want to put inside of this apple here. Okay, and it says here at index, we have to insert here what index, which index we are interested in to put this value, right? So in this case, we want to put inside of index 0. Now you will notice something interesting here. What happens here is that it bumped apple one index up, and instead of and in place that we put the new value, which is exactly what we wanted to do here. Right? If you look closely here to the right, it says new value. Let me make this a little bit bigger. Okay, so it says here new value, apple, right? But before it was just apple, mango, grape. Now our index 0, we have added a new value. Let's do the same with our array here. Let's say we want to put something else on index 0 as opposed to having 12. Let's say we want, so what do we do here? We say my array dot insert. Well, we want to insert, let's say 234 at what index? Instead of 0, let's say we want to put at index 3, which was going to be 0, 1, 2, 3. So over there, let's say 3 here. Let's see what's going to happen. All right, and there we go. So let's comment all of this out here. Okay, so I highlight everything, I select everything, and I go Command /. So everything is highlighted there, is commented out. And let's move all of this here to the top here. That way we don't get confused. Now it's much better. Okay, so as we were saying, so now my string that insert new value at index 0. So as you can see now, the apple is on index 1 because we have added new value to index 0. That's what we did here to our myString array. The same thing we can do to my array of integers. So we're saying here at index 3, we are going to insert 234. It used to be 10. As you can see now, 10 is the last one and 234 is index 3. All right. The other thing we can do with arrays is we can remove items from array. So to remove items from an array, what we can do, let's use the myString again example. So myString array dot, and right when you hit the dot key, you see there is a lot of options here. But once we start typing remove, you notice there's few options here. We are going to explore this too here, the remove at index and remove last. Now, the remove at index means that we will remove an item at certain index that we specify. So we can say enter here, and then here we have to pass the index. Let's say we want to remove grapes. So we know that grapes is going to be on index 2 because remember the first one is always 0. So 0, 1, 2. So here we just go ahead and put 2. And you see right away mango is what was removed. And you start wondering, well, but I said here I want index 2, but 2 is not mango. It should be grapes that's removed, right? Well, it turns out, you have to remember something here. We actually added this new value to this array here. So the actual array, so when we said 2, we actually saying 0, 1, 2 here, which is mango. So this is correct, even though what we intentionally wanted was to remove grapes from according to our first array here that we created before we had added anything to it. This is wrong, right? Because remember, we've added this new value here. So according to this new array here, this is correct. But if we just look at this first one, it's going to be wrong, right? So in this case here, of course, 2 is going to be 0 to the right here. So new value is 0, apple is 1, and mango is 2. That's why it's showing 2. That's why it's showing mango here. Okay, so let's print this here to see here. Let's say print myString, and we'll see now what it's there. So it's new value, apple, grapes, because we got rid of mango. Okay, perfect. Now we can go ahead and do the same with our int. So we can say my array, which has a lot of integers here. We can say that remove at index. Let's say we want to remove at index. Let's look at here to the right, because this is what our current my array contains. Let's say we want to remove 11. So that would be index 1. Just put 1 here. We should remove 11. So as you can see, 11. If we print my array, we'll see we won't have 11 anymore. Okay? And the other thing we can do is we can use the other remove. So we can say myString array dot remove last. Remove last will remove the last item encountered inside of this myString array here, which in this case is grapes. As you can see here, our myString array has new value, apple, mango, and grapes. And grapes indeed is what's removed. And we can do the same with my array that remove last, and that's going to happen. Let's print that out again. Print my array, and you see 12, 56 to 34 is removed from the original one. All right, very fun. So you can go ahead and play around with this concept, all these things you can do with arrays, which is really, really amazing. All right, so now you know what arrays are. So you know how to create arrays that will hold integers, strings, and potentially you also know how to create arrays that would hold doubles. All right, and that's actually going to be your challenge, how to create an array that will hold doubles. Just remember, you can implicitly create any array just like we did here with our integers. Remember that doubles have decimal points. How would you create arrays that hold doubles? All right, so I gave you the hints, so I hope you can manage it. As an exercise, I want you to go ahead and create an array named prices. And this array will hold prices such as 19.90 or 20.30 or 19.00. So all of numbers that have decimal points, that's what that array is going to hold. And then you go ahead and do all of these things that we've done here, like removing things, adding things, removing from last, and all of this. So that's going to be your challenge, and I know you're going to be able to manage it, and I will see you in the next videos. So in the previous video, we talked about arrays, and we now know what arrays are and how to create arrays in Swift. We also know that arrays have index, so everything is ordered, has a certain order. Each index points to an item or a value. In this video, we are going to proceed and talk about dictionary. So in this case, our dictionary has the same kind of idea of a real-world dictionary, where you have a word and then you have the meaning of the word. Dictionary in Swift stores associations between keys of the same type and values of also of the same type as well. So all of this will happen in a collection with no defined ordering. As you can see here, these examples, we have here keys. As a column of keys, we have YYZ. You see this YYZ here points to Toronto Pearson, okay, as its value. And then we have DUB, which points to Dublin Airport. We have the LHR, which is London Heathrow, okay? So that's the key concept here about dictionaries. So just think of a key value pair association, which allow us to connect, which will allow us to store data. Okay, so let's go ahead and take a look on how to actually use dictionaries. This string here, okay, so dictionaries, let's say here, dictionaries. All right, how do we create a dictionary? Well, you may have guessed by now, so we start by saying var. I'm going to call this my dictionary. So we can go ahead here. We will start with the implicit way of creating a dictionary. So we're gonna go ahead and say my dictionary is equal to, we will put here our square bracket just like we did with arrays. Let's close that. However, look what's going to happen here. Now that we have our square bracket, we said that we need to have a key value association, which means, let me put here, so it has to be key, and then this key will be pointing to a value. Right? So what we need to do here, first thing we do, we have to have a key. So a key, in this case, we're going to have a string. We're going to say, for instance, we're going to go ahead and say bank as the key. And then notice what we're going to do. We're going to put a colon here. All right? So this colon here, it's going to be, so think of this colon as saying, okay, this bank is the key for the value we're going to put here. So we can say money, just like that. Okay, so now we have this key pair of value here because we have the key bank and the value we want to associate to bank is money, right? So let's go ahead and print this out here. So print and say my dictionary, and fair enough, we're gonna have bank money. Now the whole idea of having key value pair association here is so that we are able not only to create a more advanced data structure or ways of holding data in our programs, but also to be able to quickly access the value, right? That's why we have a key. The reason why in the real world you have a key is to open something and access something, right? If we just print my dictionary, it will just show the entire association, bank and money, right? What we can do if we want to just get the money, so through our key, we can say square brackets and we say bank, and it says here optional money. Now this optional money here, obviously we didn't write any optional, so we have no idea where this comes from. We'll talk more about it later, okay? I don't want to complicate things, but to actually get this to work, we will need to put an exclamation mark after our last closing square bracket here, all right? So that way we actually get money, which is the key, which is the value to this key here. We're accessing our value through our key. All right. Now we can obviously put as many key value as needed. So the way we do that, we just put comma and we'll put another key. We can say, let's see, food. We can go ahead and say restaurant as the key, and the value we can say food. If we want to access food, obviously we can go ahead here and say restaurant, and guess what? We're gonna see food. As we've been learning so far, we notice there's always two or more ways of doing the same thing. Now, if we want to explicitly say what type of values we're gonna put in our dictionary, right? So we can go ahead and say my string dictionary. We're going to say comma and have here square brackets, and inside we're going to say string colon string. I'm going to have a space here, and then once we have that, that's when we go ahead and actually create the associations we want. In this case, we can go ahead and say home. I guess home we can associate with happiness. Work, if you love your work, you will associate it with fun. You may not have the same sentiment, but I hope you do. All right, so here we go. Again, this is the same. The bottom one here on line 8 is the same as what we have on line 7. It's just that we are deliberately telling the system and ourselves that, okay, this dictionary we are going to create is going to hold strings, which is exactly what's happening here. Now, if we wanted, obviously, you've guessed now, if you want to create a my int dictionary, we could have done the same thing, except, yes, you guessed it. What do we do here? Well, we can go ahead and just say, for instance, 156 like that. Okay, this is now, and then put it the second one. You can say 2 is 123. 3 is pairing with 78, as you can see here, right? So if we want to go ahead and print out the int, we can say print my int dictionary, and what do we do? Again, square brackets, and let's say if we want to know what's the value of key number 2 here, we actually get the value here by putting this optional here, which is just a exclamation mark here. All right, so there we go, 123, and it's indeed here 2 points to 123. The other way to think about this, if it's a little bit confusing now, if you look at bank, let's go back to our first example. If we look at bank here, the way you want to read this is bank points to money, which means if I want to access money, I go to bank. Restaurant points to food. If I want to get food, I go to a restaurant. That kind of helps understand what this dictionary's key value, what they do. The same things we were able to do with arrays, like accessing and modifying arrays, we are also able to do when it comes to dictionaries. Let's say if we want to find out the count of my dictionary variable, what would we do? Let's say find count. Well, simply we'll just go ahead and say my dictionary, right? Because we have our dictionary variable here. My dictionary dot count. And indeed, you will see here it says 2. Why is it 2? Because if you look here, we have bank, money, and then comma, and then restaurant. So each one of these counts as 1. So everything is kind of delimited by a comma. Bank, money is 1. Restaurant, food is 2. All right, so we can go ahead and find the count also of our my string here. Dictionary, so my string dictionary dot count, and you will see here it says also 2. Why? Because we have home, happiness as one entity, and then we have work, fun as another one. All right, great. The other thing we can do here is we can go ahead and add something to our dictionaries. right? Add items to dictionaries. All right. So what we can do to add, simply we can go ahead, let's say, using our example here in my dictionary, say, let's go ahead and say my dictionary again. We can go say and open our square brackets, and then we put the key we want to add. In this case, we can say, for instance, MT, right? That's and say equals to Montana. So Montana is one of the states in the United States of America. So as you can see here, MT, we were saying here, now we are adding to my dictionary, which is this dictionary here, right? MT key, and we're associating this MT key with Montana. Now let's see if this is true. Let's go ahead and print again my dictionary here and see what's going to happen. And you can see MT, Montana, bank, and all of that. Let me make this a little bit bigger here so we can see everything. Right? MT, Montana. Then we go forward. Bank, money, restaurant, food. Very nice. Perfect. And so you can do the same with our my int dictionary here. Now, a little challenge for you. Go ahead and add, say, key 5, a value of 128. So challenge, add key to be 5, value, what did I say? Doesn't matter. Value, we can say 456. Okay? Let's see there. I'm pretty sure you can manage this. Challenge here. Okay, little typo, that's fine. Okay, all right, so I know that you were able to manage to get that working. So if not, don't worry. What we would do is we would say, in this case, my int dictionaries, and then enter, and which is this here. Okay, and then we would go ahead and open our square brackets, and then we'll put 5 as the key. Finish that, and then we would say equals 456. Let's print here to make sure this is actually working. Let's print my int dictionary. And there it is, 5456, right? So 5 the key, and the value is 456, which is indeed what we wanted. Perfect. Good. That's wonderful. Now let's see also what else can we do with our dictionaries. Okay. The other thing we can do with our dictionaries, let me give more space here. The other thing we can do with our dictionaries is we can also go ahead and update certain value. Let's say we are deep in our program and we realize, okay, we need to change the bank value. We need to update, I should say, we need to update our bank value, our bank key and give it a different value, right? How do we do that? Now, the beauty of all of these data structures or ways of which we can tools, or I would say methods or classes that Swift comes with, that allows us to access and modify data, is that each time, you've noticed here, when I start typing, say, my dictionary here, let's go ahead and do it right now. The moment I start typing, say, my dictionary, and I say dot, which means I want to access something, look all of this that's happening here. There's a lot of things that I know may seem very strange to you or foreign. That's okay, we'll get into that in later videos. But you see, all of these are just things that we can do to our dictionary, right? So we talked about the count. We can see if the dictionary is empty, which is going to return a boolean, which essentially says true or false. Okay, we can remove all, and a lot of other things that we are not very interested in right now. That's great. So as you can see, the libraries that come with the Swift language has a lot of already pre-built functions or methods and classes that allow us to literally just call these methods and do things with our data, which is wonderful. That's the beauty of Swift, or any other language for that matter. Okay, great. Now let's say if we wanted then to go ahead, like we wanted to update a certain value, what we would do? We say dictionary, my dictionary in this case, dot update, and you can see right away the moment I type up, it just goes and knows, oh, you probably mean update value. And look what's happening here. Again, we will talk about this into more details later. Right now, just follow along, okay? If you don't understand, it's all good. So it says here update value, but inside there are values that we are supposed to pass in. In this case, it's saying the value, we need to pass a value, and then we also have to pass the key that we want to change. Okay, so in this case, let's say if the value we want to change is, instead of saying money, we want to say security or something like that. And the key, well, what we want to change, we have to say, let's go back, is bank, right? So we have bank here. So what we just did here, we just said we want to go ahead, instead of having money as the value of our bank, for our bank here, key, we want it to actually be security. Let's see if this works. Let's go and say print my dictionary here. My dictionary. Let's see what's going to happen. Aha, look here to the right. We still have MT, Montana. Bank now does not say money. Instead, it says security, which is exactly what we wanted, because we said here the value, it's going to change, be updated to security for which key? For bank, right? And of course, again, we can do the same to our int. We can say my int dictionary dot update. What we want to update to 980, for instance. What is the key? Let's say we want to change the 7 to 8 here. So the key is 3. So we have to put 3 here. And let's go ahead and print my int dictionary. Instead of 7 to 8, it should say 980. Let's see. Indeed, 3 says here 980. I'm hoping you can start seeing here all the things you can do with dictionaries and arrays. Very powerful. So many things we can do. And as we proceed in this course, I will show you, you will see all of these being put into place, where things are going to start making sense as to why we are even talking about these things. Okay? Good. Perfect. All right. The same thing here, what we can also do, since we are updating, guess what? We can also remove items from our dictionaries. Well, following our examples here, let's go ahead and keep using my dictionary. All right, so my dictionary, there it is. We're going to go ahead and say dot remove. We're going to use the remove value for key. So we're using a key. So click on that one and say enter. So we want to remove a key, which means we'll also remove the value. Since it's only removing the key, why is it removing the value? Well, the reason why if you remove the key, it removes the value is because the whole idea of having this key pair association is so that we have that association, that connection between the key and the value, right? Which means if we want to remove the value, we go and remove the key, because key is totally connected to the value. But that's the whole point of having this key pair value. One doesn't exist without the other, right? So if we want to remove the value, we go ahead, we go after the key. All right. So in this case, let's say if we want to remove, let's see what we would want to remove. Let's remove the security again. Well, the key is bank, and we close. So it says here security, which means that's exactly what was removed. Let's print this out and make sure it's true. Let's go and say print my dictionary. If this is true, then we won't see bank money or bank restaurant or bank security. Indeed, there's no more bank here. And we can do the same, of course, with our integers. We can go ahead and say my int dictionary dot remove, right, value for key, and we pass, let's say we want to remove this 5 key here, which is the one we inserted earlier. We can just go ahead and put 5 in there. And it should say here 456 indeed. And let's print that out. My int dictionary. And we should see here, there's no more 456, nor is there 5 key. So great. So we've learned a lot in this lecture here. So I hope it wasn't too overwhelming. The main thing I want you to get out of this lecture here about dictionary is that they are key value association. Right? So we have here bank, which associates to money, meaning that if I want to access money, I go after the bank. Okay, that's all that's happening here. Just think of bank points to money. That's all what's happening. All right, great. Well, now the other thing I want you to do, again, go ahead and play around with this concept here. Remove value for key. Go ahead and explore other methods, other things you can do with the dictionaries. For instance, here my int dictionary dot. For instance, let's go and find something. Let's say the boolean is empty. What does that do? Let's get that one and see. What does it say? It's going to say false, which means this my dictionary that is empty is asking whether or not the dictionary is empty, and it returns false because indeed my dictionary is not empty. Why? Well, my dictionary has things inside of it. Okay, so go ahead and explore this. You won't break anything. Don't be afraid of exploring and trying. The more you explore, the more you learn. Great job, and I will see you in the next video. So in the previous video, we talked about arrays, and we now know what arrays are and how to create arrays in Swift. We also know that arrays have index, so everything is ordered, has a certain order. Each index points to an item or a value. In this video, we are going to proceed and talk about dictionary. So in this case, our dictionary has the same kind of idea of a real-world dictionary, where you have a word and then you have the meaning of the word. Dictionary in Swift stores associations between keys of the same type and values of the same type as well. So all of this will happen in a collection with no defined ordering. As you can see here, these examples, we have here keys. As a column of keys, we have YYZ. You see this YYZ here points to Toronto Pearson, okay, as its value. And then we have DUB, which points to Dublin Airport. We have the LHR, which is London Heathrow. Okay, so that's the key concept here about dictionaries. So just think of a key value pair association, which allow us to connect, which will allow us to store data. Okay, so let's go ahead and take a look on how to actually use dictionaries. This string here, okay, so dictionaries, let's say here, dictionaries. All right, how do we create a dictionary? Well, you may have guessed by now, so we start by saying var. I'm going to call this my dictionary. So we can go ahead here. We will start with the implicit way of creating a dictionary. So we're gonna go ahead and say my dictionary is equal to, we will put here our square bracket just like we did with arrays. Let's close that. However, look what's going to happen here. Now that we have our square bracket, we said that we need to have a key value association, which means, let me put here, so it has to be key, and then this key will be pointing to a value. Right? So what we need to do here, first thing we do, we have to have a key. So a key, in this case, we're going to have a string. We're going to say, for instance, we're going to go ahead and say bank as the key. And then notice what we're going to do. We're going to put a colon here. Right? So this colon here, it's going to be, so think of this colon as saying, okay, this bank is the key for the value we're going to put here. So we can say money, just like that. Okay, so now we have this key pair of value here because we have the key bank and the value we want to associate to bank is money, right? So let's go ahead and print this out here. So print and say my dictionary, and fair enough, we're going to have bank money. Now, the whole idea of having key value pair association here is so that we are able not only to create a more advanced data structure or ways of holding data in our programs, but also to be able to quickly access the value, right? That's why we have a key. The reason why in the real world you have a key is to open something and access something, right? If we just print my dictionary, it will just show the entire association, bank and money, right? What we can do if we want to just get the money, so through our key, we can say square brackets and we say bank, and it says here optional money. Now this optional money here, obviously we didn't write any optional, So we have no idea where this comes from. We'll talk more about it later, okay? I don't want to complicate things. But to actually get this to work, we will need to put an exclamation mark after our last closing square bracket here, all right? So that way we actually get money, which is the key, which is the value to this key here. We're accessing our value through our key. All right. Now we can obviously put as many key value as needed. So the way we do that, we just put comma and we'll put another key. We can say, let's see, food. We can go ahead and say restaurant as the key, and the value we can say food. If we want to access food, obviously we can go ahead here and say restaurant, and guess what? We're gonna see food. As we've been learning so far, we notice there's always two or more ways of doing the same thing. Now, if we want to explicitly say what type of values we're gonna put in our dictionary, right? So we can go ahead and say my string dictionary. We're going to say comma and have here square brackets, and inside we're going to say string colon string. I'm going to have a space here, and then once we have that, that's when we go ahead and say, that's when we go ahead and actually create the associations we want. In this case, we can go ahead and say home. I guess home we can associate with happiness. Work, if you love your work, you will associate it with fun. You may not have the same sentiment, but I hope you do. All right, so here we go. Again, this is the same. The bottom one here on line 8 is the same as what we have on line 7. It's just that we are deliberately telling the system and ourselves that, okay, this dictionary we are going to create is going to hold strings, which is exactly what's happening here. Now, if we wanted, obviously, you've guessed now, if you want to create a my int dictionary, we could have done the same thing, except, yes, you guessed it. What do we do here? Well, we can go ahead and just say, for instance, 156 like that. Okay, this is now, and then put it the second one. You can say 2 is 123. 3 is pairing with 78, as you can see here, right? So if we want to go ahead and print out the int, we can say print my int dictionary. And what do we do? Again, square brackets. And let's say if we want to know what's the value of key number 2. 2 here, we actually get the value here by putting this optional here, which is just a exclamation mark here. All right, so there we go, 123, and it's indeed here 2 points to 123. The other way to think about this, if it's a little bit confusing now, if you look at bank, let's go back to our first example. If we look at bank here, the way you want to read this is bank points to money, which means if I want to access money, I go to bank. Restaurant points to food. If I want to get food, I go to a restaurant. That kind of helps understand what this dictionary's key value, what they do. The same things we were able to do with arrays, like accessing and modifying arrays, we are also able to do when it comes to dictionaries. Let's say if we want to find out the count of my dictionary variable, what would we do? Let's say find count. Well, simply we'll just go ahead and say my dictionary, right? Because we have our dictionary variable here. My dictionary dot count. And indeed, you will see here it says 2. Why is it 2? Because if you look here, we have bank, money, and then comma, and then restaurant. So each one of these counts as 1. So everything is kind of delimited by a comma. Bank, money is 1. Restaurant, food is 2. All right, so we can go ahead and find the count also of our my string here. dictionary. So my string dictionary dot count, and you will see here it says also two. Why? Because we have home, happiness as one entity, and then we have work, fun as another one. All right, great. The other thing we can do here is we can go ahead and add something to our dictionaries, right? Add items to dictionaries. All right, so what we can do to add, simply we can go ahead, let's say using our example here in my dictionary, say let's go ahead and say my dictionary again. We can go say and open our square brackets, and then we put the key we want to add. In this case we can say, for instance, MT, right? That's and say equals to Montana. So Montana is one of the states in the United States of America. So as you can see here, MT, we were saying here, now we are adding to my dictionary, which is this dictionary here, right? MT key, and we're associating this MT key with Montana. Now let's see if this is true. Let's go ahead and print again my dictionary here and see what's gonna happen. And you can see MT, Montana, bank, and all of those. Let me make this a little bit bigger here so we can see everything, right? MT, Montana, then we go forward, bank, money, restaurant, food. Very nice, perfect. And so you can do the same with our my int dictionary here. Now, a little challenge for you. Go ahead and add, say, key 5, a value of 128. So challenge, add key to be 5, value, what did I say? Doesn't matter. Value, we can say 456. Okay? Let's see there. I'm pretty sure you can manage this. Challenge here. Okay, little typo, that's fine. Okay, all right, so I know that you were able to manage to get that working. So if not, don't worry. What we would do is we would say, in this case, my int dictionaries, and then enter, and which is this here. Okay, and then we would go ahead and open our square brackets, and then we'll put 5 as the key. Finish that, and then we would say equals 456. Let's print here to make sure this is actually working. Let's print my int dictionary. And there it is, 5456, right? So 5 the key, and the value is 456, which is indeed what we wanted. Perfect, good. That's wonderful. Now let's see also what else can we do with our dictionaries. Okay, the other thing we can do with our dictionaries, let me give more space here. The other thing we can do with our dictionaries is we can also go ahead and update certain value. Let's say we are deep in our program and we realize, okay, we need to change the bank value. We need to update, I should say, we need to update our bank value, our bank key and give it a different value, right? How do we do that? Now, the beauty of all of these data structures or ways of which we can, tools, or I would say methods or classes that Swift comes with, that allows us to access and modify data, is that each time, you've noticed here, when I start typing, say, my dictionary here, let's go ahead and do it right now. The moment I start typing, say, my dictionary, and I say dot, which means I want to access something, look all of this that's happening here. There's a lot of things that I know may seem very strange to you or foreign. That's okay, we'll get into that in later videos. But you see, all of these are just things that we can do to our dictionary, right? So we talked about the count. We can see if the dictionary is empty, which is going to return a boolean, which essentially says true or false. Okay, we can remove all, and a lot of other things that we are not very interested in right now. That's great. So as you can see, the libraries that come with the Swift language has a lot of already pre-built functions or methods and classes that allow us to literally just call these methods and do things with our data, which is wonderful. That's the beauty of Swift or any other language for that matter. Okay, great. Now let's say if we wanted then to go ahead, like we wanted to update a certain value, what we would do? We say dictionary, my dictionary in this case, dot update, and you can see right away the moment I type up, it just goes and knows, oh, you probably mean update value. And look what's happening here. Again, we will talk about this into more details later. Right now, just follow along, okay? If you don't understand, it's all good. So it says here update value, but inside there are values that we are supposed to pass in. In this case, it's saying the value, we need to pass a value, and then we also have to pass the key that we want to change. Okay, so in this case, let's say if the value we want to change is, instead of saying money, we want to say security or something like that. And the key, well, what we want to change, we have to say, let's go back, is bank, right? So we have bank here. So what we just did here, we just said we want to go ahead, instead of having money as the value of our bank, for our bank here, key, we want it to actually be security. Let's see if this works. Let's go and say print my dictionary here, my dictionary. Let's see what's going to happen. Aha, look here to the right. We still have MT, Montana. Bank now does not say money. Instead, it says security, which is exactly what we wanted, because we said here the value, it's going to change, be updated to security for which key? For bank, right? And of course, again, we can do the same to our int. We can say my int dictionary dot update. What we want to update to 980, for instance. What is the key? Let's say we want to change the 7 to 8 here. So the key is 3. So we have to put 3 here. And let's go ahead and print my int dictionary. Instead of 7 to 8, it should say 980. Let's see. Indeed, 3 says here 980. I'm hoping you can start seeing here all the things you can do with dictionaries and arrays. Very powerful. So many things we can do. And as we proceed in this course, I will show you, you will see all of these being put into place, where things are going to start making sense as to why we are even talking about these things. Okay? Good. Perfect. All right. The same thing here, what we can also do, since we are updating, guess what? We can also remove items from our dictionaries. Well, following our examples here, let's go ahead and keep using my dictionary, right? So my dictionary, there it is. We're going to go ahead and say dot remove. We're going to use the remove value for key. So we're using a key. So click on that one and say enter. So we want to remove a key, which means we'll also remove the value. Since it's only removing the key, why is it removing the value? Well, the reason why if you remove the key, it removes the value is because the whole idea of having this key pair association is so that we have that association, that connection between the key and the value, right? Which means if we want to remove the value, we go and remove the key, because key is totally connected to the value. But that's the whole point of having this key pair value. One doesn't exist without the other, right? So if we want to remove the value, we go ahead, we go after the key. All right. So in this case, let's say if we want to remove, let's see what we would want to remove. Let's remove the security again. Well, the key is bank, and we close. So it says here security, which means that's exactly what was removed. Let's print this out and make sure it's true. Let's go and say print my dictionary. If this is true, then we won't see bank money or bank restaurant or bank security. Indeed, there's no more bank here. And we can do the same, of course, with our integers. We can go ahead and say my int dictionary dot remove, right, value for key, and we pass, let's say we want to remove this 5 key here, which is the one we inserted earlier. We can just go ahead and put 5 in there, and it should say here 456 indeed. And let's print that out. My int dictionary, and we should see here there's no more 456, nor is there 5 key. So great. So we've learned a lot in this lecture here. So I hope it wasn't too overwhelming. The main thing I want you to get out of this lecture here about dictionary is that they are key value association, right? So we have here bank, which associates to money, meaning that if I want to access money, I go after the bank. Okay, that's all that's happening here. Just think of bank points to money. That's all what's happening. All right, great. Well, now the other thing I want you to do, again, go ahead and play around with this concept here. Remove value for key. Go ahead and explore other methods, other things you can do with the dictionaries. For instance, here my int dictionary dot. For instance, let's go and find something. Let's say the boolean is empty. What does that do? Let's get that one and see up. What does it say? It's going to say false, which means this my dictionary that is empty is asking whether or not the dictionary is empty, and it returns false because indeed my dictionary is not empty. Why? Well, my dictionary has things inside of it. Okay, so go ahead and explore this. You won't break anything. Don't be afraid of exploring and trying. The more you explore, the more you learn. Great job, and I will see you in the next video. And how to use it. Let's say we want to check to see if a person at a certain age is eligible for retirement or not, right? So the first thing I'm going to do, I'm going to say var retirement age in the United States, I believe, is 65 years. So if you're 65 years old, you can retire. So here we can say if, right, retirement age is less than or equal to 32, we put our braces there. Let's say you are not ready to retire. We have intermediate values in which we need to check to make sure that if that person is eligible for retirement. We can then say else if retirement age is greater than or equal to 65, then we want to run some other code. We can say print value. We can say congrats, you can retire now. In case this else if statement is not true, or this first if statement here branch doesn't trigger or doesn't run, then we can run an else statement here. So that's the last resort. If none of these are true, then the last resort that's going to run here has to be this else. We can say print. Let's go ahead and just print something silly here. Well, I'm not sure about your situation. So let's go back to what's happening here. We know the retirement age is 65. So now we are checking if a retirement age is less than or equal to 32, then we're going to say you are not ready to retire. Else if retirement age, which is 65, is greater than or equal to 65, then congrats, you can retire. Else, well, I don't know what to tell you. Okay? So you can see this logic here. We are branching out and triggering different branches as we go along. Now you can see how you can branch out and make different decisions depending on the retirement age. Wonderful. I'm hoping that by now you started seeing power of if statements and else if and else, and how you can use this knowledge to literally start creating a little bit more dynamic and complex little programs on your own. So go ahead and explore a little bit more this concept here on your own, which again is the best way to learn how to program in Swift. All right. Okay. So congratulations again, and I'll see you in the next video. That's when we use loop controls. So essentially, loop control allows us to repeat the execution of a code block a number of times. We do have a few loop control we are going to be learning. The first one is the for loop, which is the most used or common one. And the next one is the while loop. All right, so let's go ahead and fire up our Xcode and start coding. So I'm going to go ahead and create a new project. So file, new, playground project. you've done this a few times now. So I'm going to call this my for loop. Say next, and I'm going to close the previous one here because we don't need it. All right, I'm going to position myself here so you can actually see the entirety of the screen here. So I'm going to go ahead and get rid of this. So the first one is going to be for loop. So the for loop allows us to go through to repeat the execution of a certain statement. So how do we start? So we say for, that's the keyword. And then we say var. In this case, we are initializing a var, a variable, which in this case we can call index. And we are initializing it to be at 0, semicolon. And then we say index is less than 5. And then we increment it. We say plus plus index. And then we create this code block here with these curly braces there. Let's print something out and see if this is actually true. So print time is, let's go ahead and actually print our index here. So we're going to say index. Right away it says here 5 times. This statement here is repeating 5 times. Now you see here it just says 5 times. In order for us to actually see what exactly how many times it's repeating in terms of what is spitting out, click on that all values. You can see it says time is 0, time is 1, time is 2, time is 3, time is 4. So this is what we intended for it to do because we wanted to go ahead and repeat the same execution. Meanwhile, the index is incremented. Okay, so let's go back and learn how to read this. So what are we doing here? We created our for loop here by saying for, and then we have a variable we call index. We could have called anything else here. We could have said I or B or D, whatever we wanted. But in this case, we said index, and we're saying index is at 0. So it starts at 0. Index is equal to 0. And we have this semicolon here, which means we're ending this statement here. This var index is equal to 0. And then we say index is less than 5. And then we increment. What we're saying here, we're saying, okay, we want to run this piece of code, this code block here inside here, where it says print time. We want to write it as long as our index is less than 5. The first time this runs, index is 0. 0 index is indeed less than 5. That's true. Therefore, it's going to put that 0 here and increment 1. So now index is 1. It goes back and says, okay, index is now 1 and goes and check. Index is equal to 1. Is it less than 5? Yes. 1 is less than 5. We increment and then this runs again. And now this index is 1. And does this same thing until the index is 5. Now, here's what's going to happen. When index is 5, let's say index is 5 here, 5 is less than 5. Is that true? No, it's not true. That's why it breaks. And that's the reason why, let's go back here to the right and click on this. That is the reason why we don't see a 5 in here. Time is 5. It stops at 4. Because by the time it gets to 5, it says, well, this is not true. And then it breaks. That's the reason why this runs 5 times precisely, but doesn't show the 5 here because we start at 0, 1, 2, 3, 4, right? And if we wanted to change this, if we put 6 here, you notice right away we have 6 times here. So we click on this little I thing to the right and go up here and we see indeed there is times 0, 1 through 5. Because now when it gets to 5 index here, it's going to say 5 is less indeed than 6. So iterate again and increment our index. So that's why you see the 5 here, as you can see to the right here. Okay, that's our for loop. We could have said, well, we want to display as long as index is less or equal to 6. Look what happened now here, because our condition is a little bit different. Is less than or equal to 6. So it's going to go 7 times. That's why it goes through 6 again, because we are including the number 6, the 6th time. Now, going back to our statement here, we said that index, we are creating a variable called index is equal to 0, because we know that this statement here, var index is equal to 0, we've seen this before. We could also just take it away from our for inside of our for loop here and actually create it outside here. Say index is equal to 0. And then here, what we can do, we can just go and refer to index. This looks a little bit more elegant, but either way, it's the same thing, right? So what are we doing here? We're just putting our index outside of our loop. So we are initializing it before we start implementing it inside of the for loop. Essentially the same thing, just a different way of organizing our code. So to summarize the general form of this loop format here, we have a for. So this next thing we have after our for keyword is the initialization. This is where we are initializing things. Well, in this case, we went back and initialized our index outside, but this is essentially, it's the same thing. So we have our initialization, and then we have our semicolon to say this is just one statement, and we have inside here the condition. After that, as you can see, the index is less than 6. That's our condition, because we're saying these are our conditions. This is what we want to happen. This is what is going to guide how many times this is going to run. And then last, we have our increment. So as we go through, we are incrementing our index and checking back to see if we have met that condition. If we haven't met, this will keep running. If we met the condition where this index is not less than 6 in this case, then we stop. So we have initialization, second we have condition, and finally we have increment. And of course then inside we have the statements that we want to run. And of course we can run as many statements as we want here. What if we wanted to go through an array and display all of the items from an array onto our screen? How would we do that? Let's create our array here. So let's say var my array again. It's going to be an array of strings. You know how to do this by now. iOS, Swift, Apple. All right, so we have our array here. In order for us to iterate through or to go through this array and display iOS, Swift, and Apple in our console here, in our logs, we can use a for loop. We say for, and we initialize here. I'm gonna go ahead and say var I for index is equal to 0, right? This is our initialization. And then I'm gonna put the condition here. I'm gonna say I is less, now pay attention here, is less than my array dot count. And notice really quick here, this count here, it says how many elements the array stores. Returns an integer, which is great because that's what we need. So what I'm saying here, while I is less than the elements that this array stores, which is the count, then we want to increment. So plus plus I. And then we put our curly braces there. And inside here, what we want to do, we want to print. So we can say print item is, and of course, we are going to append, concatenate here. We're going to say my array, and we're going to open square brackets there. And we are going to say I, because we're passing in the index as it iterates. Let me show you something really neat here. If you look in our logs here, just go to the right where it has this I here. If you click on the far show result plus sign there, here, click on that, look what's going to happen. It's going to show it here. And if you hover over, it's going to give you an option of just one item or a list of whatever it's being displayed. So now you can see here that it's running items is iOS, which is the first one. Item is Swift, second, and third is Apple. All right. And then we can go ahead and close this down here by clicking there. Let's understand what's happening here. So we went ahead and create our my array of strings. So it has iOS, Swift, Apple. So once we have our array, we have our for loop here. So again, we went ahead and say var I, because that's our index. So we just said I is equal to 0. We are initializing our for loop block, and then we have our condition. Now here, what we're saying is we are checking to see if I is less than my array dot count. We could have just said, well, because we know our my array is size 3, we could have just added 3 here instead of putting my array.count. Now, the reason why I didn't put 3 is that what if I wanted to change this to a different size? What if I added orange and other things inside of this array? Then I would have to come back here and change to 4 or 5 to make sure that as the same size as I put more stuff here in this array. Well, that is not very dynamic, and it's not a good habit to have in programming, right? We want to make sure that when we write our programs, they can adjust to whatever conditions as conditions change. Okay, so that's what we're doing. And here, of course, we are incremented our I, our index. So it goes first time, and second time until this condition here doesn't hold true, and then it stops. Here, this is what's happening. We are going back and say my array. We're taking this my array again, and then we are passing in the I. So first time is going to go around, it's going to be 0. So my array indexed at 0. So this I is going to be 0 here. It's going to go back and look at my array. Well, at 0 index, guess what? We have iOS, and item is iOS. That's what's going to show. The second time, the I is 1. So it goes back, says my array, and passes in the 1. And guess what? At index 1, we have Swift, and you see here it says item is Swift. The next way of iterating through an array using a for loop, we're going to use what's called a for in loop. Now, this one is really slick because it's much compact. So how we do this one here, we go ahead and say for, and the next thing we have in our for in loop, we create a variable. In this case, we know we are iterating through my array. Let's just call this M array. And then we say in my array. Notice now this my array is what? Is this my array that we have up here. And then we have our braces there. And we say print. And now here, what we're going to do, we're going to say the same thing. We say item is. Now, notice what's going to happen here. Let's put a comma. And then we're going to go ahead and append, so backslash, open parenthesis and close, M array. What is this M array? Is this M array variable we created here. And let's take a look. So item is, let's make it more so it shows everything. So as you can see, it's the same thing that we had here, except it's just the syntax, right? So we are getting the same values because we haven't changed anything. It's just a different syntax. So we are still getting iOS, Swift, Apple, Orange. Close this here. Click there. This for in here loop is different from our previous for loop here. They call it traditional for loop. It's different in that all we had to do, we just have two items in our statement here. We have our initialization here, which essentially we're just initializing a variable which will then hold whatever is coming from my array. So we are saying here M array in my array. So inside of our code block here, what's going to happen then, we can just use this M array, this what we initialize here, to iterate through my array. Very simple, right? Whereas here, we had to go back and create my array.count and increment it. And then inside, we had to go ahead and fetch the I, which is the index, and then go through that. So these are the two for loops that you can use to iterate through an array. All right. And we'll see also how to iterate through a dictionary and so forth. I want you to go ahead and experiment a little bit more with these two kind of for loops so that you can start having a hang of it. So in the next video, we'll be learning about while loop and also how to iterate other data structures. All right, so I'll see you in the next video. Ages. All right, so I'm going to go ahead and create a dictionary with some of my family members' ages. All right, so let's see. My older brother is around 52. And then let's see, I have Ruti. She is 49. And then we have Adelina. She is 45. Okay, that's enough. All right, this is our dictionary. So remember, dictionary hold key value pair association. So around here is associated with 52. So around is our key and 52 is the actual value. Ruti is the key and value is 49. Okay, so that's how dictionaries work. Excellent. Now, in order to iterate through, we're going to use the for in loop. In this case, we want to be able to have the key, which is the name, and the value. And we want to keep track of those two values. Naturally, we would want to initialize two variables in our for in loop. In here, we only had one variable. So in this case, we want to initialize two variables which will relate to the key and the actual value. This is what I'm talking about. So what we're going to do here, we're going to say for, and then we're going to open parentheses and close. Inside here, we are going to put these two variables, which we are going to initialize, and then we're going to use those variables to then iterate through our dictionary. So what I'm going to do, the first one is going to be name. The second one, I'm going to call it age. And then I'm going to say in what? It's going to be family ages. And then braces there, and there we go. So now here I have two two initialized variables, if you will, which will relate to the key and the value, which indeed is the name and the age. I can say print, and then I can just go ahead and say quotes there. And I'm going to go ahead and then append, so backslash and open parenthesis and close. So inside here, I'm going to just go and say name. I'm going to put an S and say age is, and then do the same thing here, append our variable, in this case age. Looping through, and we're passing in our name because our name will have the actual name or keys inside of our dictionary. So it's going to go first time, it's going to say Aaron. Aaron's age is 52. Second time, it's going to say Ruthi's age is 49. Third time, Adelina's age is 45. Okay, let's see if that's true. Indeed, it says that. Let's click on this icon there, and there you have it. It says Aaron's age is 52, Ruthi's age is 49, Adelina's age is 45. So you can see here, the same way we did the for in loop with just simple arrays, we can do the for in loops with dictionaries. With one difference here, which is, as we know, dictionaries have this association going on here, which is the key and the value. With that in mind, we don't have to, but in this case, we want to obviously show the key and the value. We then initialize here these two name and age variables, which then we use those two variables to access what we have in our family ages, which is our dictionary. Okay, so I want you to go ahead and create your own family ages dictionary. So you put, if you have a few brothers and sisters, or if you don't have any brothers and sisters, you can use uncles or aunts or grandparents, or you can just use animals and create an association, create a dictionary here, just something like this, and learn about looping through just like we did here. All right, wonderful. All right, so we'll stop here in this video because we have a little bit more information here to digest. And if you have any questions, please don't hesitate to ask, right? That's what I'm here for. Always ask if you have any questions, or if something doesn't just make any sense, just ask in the forums. Just create a new discussion and type away your questions or concerns you have, and I'll be more than happy to help. So I'll see you in the next video. The first thing we need to do, we need to go ahead and initialize a value. Okay, so say var I, that's for index, is equal to 0. And then we use the keyword while, you can say I is less than 5, put brackets there, and we go ahead and say I plus plus. Now here, what we're gonna do, we're gonna say print, let's say it ran, and then let's append the index, the I in this case, times. All right, so there we go. These are our syntax. So we have our initialization here, right? I is 0, and then we say while I is less than 5, we want this to run. And as it runs, we are incrementing our index, our I. Okay, as of last week, Xcode was updated. So previously we had a beta Xcode. In fact, if you go back to the videos where I show you how to install Xcode, I said specifically that we had to install the beta Xcode. Well, turns out that now they have a full version running, which is this that I'm running right now. And you can see here, if you go at top and say Xcode, click that and say about, you'll notice here it's not a 6 anymore, it's a 7.0.0, which means it's the full Xcode, production Xcode. And you notice there's no beta or anything here in the icon. Always update your Xcode as Apple release new updates. Now with that, you notice here at the bottom, I opened this up on purpose. With that, you can see now we have a console here at the bottom, right? So we can see here, this is where when we run our application, when we run this code here, this is where it's showing everything here. If you hover over at the top here, as you can see, the cursor changes here. So you can actually drag, snap it down there, or open it like this. All right, so now we have that. So there it is, you have our while loop here. So essentially it goes ahead and runs until this condition here is not true. true, doesn't hold true anymore. The next variation of a while loop is called repeat while. So in order to create a repeat while loop, you just go say repeat, and notice there's two repeats here. So we want the second option here, which is lowercase, right? We're not going to be using the repeat with uppercase here. So the second one there, say enter. And our repeat while, you go ahead and say, put at the bottom here, while, right? Parentheses. And before we go anywhere, we're going to go ahead and say var index is equal to 0. That's our initialization. And here we can go and say index, while index is less than 5. That's when inside now we are able to go ahead index plus plus, and now we can say print running, and we're gonna append our index here so we can actually see the values. Okay, so running 0 now, running 1 now, 2, 3, and 4. Now notice something very interesting here. The repeat while will always run at least once before it goes ahead and checks for our condition. So if you're writing a program that you want to make sure that this, what's inside here, what's inside of our body, runs at least one time before it checks condition, then you should use the repeat while. Again, as usually, just practice this concept here on your own. And if you have any questions, feel free to ask them in the discussion area, and I'll be more than happy to help. All right, so I'll see you in the next video. Is a function. A function is an enclosed group of statements that perform an operation, so that do something for us, right? So with functions, we can do a lot of things. The first thing we can do, we can pass in parameters or arguments, which we can then use those to do things in our code, in this block of code, and then we can return something back once we have processed all of those statements. We've looked at functions all along. You may not have realized that, but you already know what functions are. At least you've seen them. All right? Well, let's go ahead then and start looking at them in more detail. All right, so I have my Xcode open here, and I went ahead and created a playground project. So I want you to do the same and name it functions. So our playground project is called functions. And remember, it's a playground, not an iOS app project. All right, so in order for us to create a function, this block of code where we can put statements, we use this notation here. So you say func, as you can see, there it is, just say enter, and then we need to add a name over this function. Let's call this show my info. Once we have the name, we have to open and close parentheses, and then we have our braces there. So this here, this statement here, tells Xcode that we are creating a function, and this function is called show my info. All right, and of course we have our braces here. This is our function body, which means this is where we put all of our statements here. Let's say for now we just want to go ahead and say print hello from the function. Save this. Okay, well, notice that if I go ahead here, let's try something. Let's go ahead here and say print and say outside. Notice right there we have outside showing, and here we also did the same. We have a print hello from the function, but yet nothing is showing here. So hello from the function is not showing. The reason why is because this print outside, this print here, which is outside of our method, is automatically called, right? But whenever we have our function, in order for us to see the things, the statements that we have written inside, we need to call it. Otherwise, it will never show. All right, so here at the bottom, we can say show. There it is, show my info. Just say enter, and you should see hello from function. So you can infer right away that you need to call functions. And you may ask yourself, well, why is it that then I need to create a function if I can always just create a print hello or do whatever I need outside? Well, the reason why, and this will become more apparent later once we start talking about classes, is because then we don't have to repeat the same code. Let's say if we wanted to show this show my info information, this print here, 25 times in different circumstances, we can now just go ahead and call it, not having to create the same statement. That's one of the reasons why functions are handy. And of course, we'll talk more later about other advantages of functions when we talk about classes. The great thing about function is that everything that is inside our braces here is considered a block, its own entity, right? So here we can even create variables. We can go ahead and say let, for instance, my name, let's go ahead and say of type string is equal to Paulo. And then we can also say let my age, let's give it type int, is equal to 29. Yes, folks, I am 29 years old. All right. Now, if we go ahead and comment this out, notice again, nothing will show because we need to call it. Okay, so let's go back like this. Now here inside, of course, you've done many times, we can go ahead and display that information, right? You can say my name is, let's go up and my name, and I am my age years old, and save. And you see my name is Paulo and I am 29 years old. That's great. So this is how you create a function. Now, the other thing we can do with functions is we can pass in arguments or parameters that we want to use inside of our body here, right? Say we want to pass in a string, we will start by typing in the name or the name of the variable that we are passing in. So say name in this case, right? And then of type string. So what we're saying here, we're saying this show info here accept a name of type string. So that means we can pass any string here and then we can use inside here. So what we can do then inside of our method here, instead of saying let my name string is equal Paulo, let's make this more dynamic and use whatever we pass in inside here and then fetch that. So here we can go ahead and just say is equal to name. Which name? Well, this string name that we're passing here. As you can see right away, we have an error here. If you click here, it says missing argument for parameter number 1 in call. Because here we have said our contract is that our showMyInfo method needs to have a parameter, an argument here passed. So we need to pass something. Let's say Ron, for instance. Now notice what happens. Now it says my name is Ron and I am 29 years old. This Ron, that's what we are passing inside of our showMyInfo. And then we are taking whatever we're passing in as a variable, internal variable, and then we're displaying here. Now you can see as we pass arguments inside of our methods, then we have a very flexible methods because now we can pass in any name here. We can say here Bob, and my name is Bob. We can say here Melissa, and it says Melissa. You can say here anything you want. You can even say cat. And save, my name is Cat, and I am 29 years old. And we can pass in as many parameters as we need. We separate those by putting comma. So the next one, let's say we want to pass in the age. We can just go ahead and say age of type, again, colons, right? And we say int, because we want to the age we want to pass, it has to be an integer. So now we can just go say copy this. And instead of doing all of this here, we just say equal and pass in the age. So we notice right away we have an issue here. So if you click on it, so it says cannot convert a value of type string to expected argument type string age int. All right. So what's saying here is that, well, we've now changed the signature, which means the contract we have here. Now we have 2 arguments, 2 parameters here. And here we're just passing 1. So what we need to do, we have to go say comma. And there's something very interesting here. You would think that we could just go ahead and say, let's say 23, and this should work. But we're going to have an error here. The reason being is because in Swift, if you have a function that has more than 1 parameter here, in this case, we have 2, any argument after the first one has to be labeled, meaning if you click here, you'll notice what's going to happen here. Fix insert age. So I have to click insert age, get enter. This is the label. We have to label it. We have to say age, colon, whatever we are going to insert. That's one important piece of information here. So now this will work. As you can see here, my name is Kat. I am 23 years old. Okay. And we can go ahead and put a few more. Let's say we want to put a boolean there. Is married, type of bool. There it is, right? Now let's go ahead and say here, let status. I'm going to call marriage status. In this case, let's just pass in our is married. Okay, so now what do we need to do? Again, we have a problem here, so that means we can go ahead here and put comma, is married. We're gonna say true. Let's change name here to Paulo, age 29, and is married is true. And now here, of course, we need to add the is marriage variable here, and we can say and marriage status is, we pass in our variable there, marriage status. And we should see here, let's go ahead and make this a little bit bigger. And you can see it says, my name is Paulo and I'm 29 years old and marriage status is, let's click on that. It says here, marriage status is true. All right. So as you can see here, you can go ahead and put as many arguments as you wish. Great, so you've learned how to create functions, you've learned how to pass in arguments in your functions, different types, and so forth. So as you can see here, we have string type, we have int, we even have a Boolean type, okay? And you've also learned how to create certain logic inside of your body here. In this case, it's just printing our values, which we are receiving in this case from our arguments. So as you can see, I can call this same method here. Let's show my info. I can put different names. Let's say Erica something, and age, I can say 24, is married, I can say false. And guess what? Look what's going to happen. If we click here, let's click at this bullseye there. As you can see, it says my name is Erica and I'm 24 years old and marriage status is false. I'm hoping you can start seeing the power of functions here. So go ahead and play around again with this concept here of functions and create your own functions. Make sure you pass in arguments, different kind of arguments, and just play around with this concept again. And if you have any questions, as usual, if you have any questions at all, don't hesitate to ask them in the discussion forums, all right? So I'll see you in the next video. Actually return things from our functions. Okay, let's go ahead and comment this out there. So save that. Let's get rid of, okay, this is all good. Return types. So we're going to go ahead and do the same thing. Let's create a function here. Let's call this func. We're going to call add numbers. I want this function here to have two arguments of type integers. So we're going to say here, first num is type int. Second num is also of type int. And then we are going to go ahead and close. In order for us to tell the compiler that this function here needs to return a type, we go say dash greater than sign, shift, and then the period key. There it is. And we can go ahead and say int. And only then we put the braces there. Let's take a quick look here at what's happening here. So we created our function. We say func. We name it add numbers. We open parentheses because that means we are creating a function. And then inside we're passing in first num of type int, second num of type int. And when we close our parentheses, and then we have this dash and greater than sign, and then we put int. Now this int here means this is the return type for this method here. Now we notice right away we have an error here, so click on that. Missing return in function, expected to return in integers. That's one thing about having this return type here, because now the system is saying, well, you told me that I need to return an int type, yet you're not returning anything here. So to finalize the contract we are making here by saying this returns an int, we actually have to say return something. Say enter. In this case, what we need to do, we want to return, for now, just put 0 here so that we don't have that error. But in reality, we want to return these two numbers we are passing in as arguments. Let's go ahead and say let sum equal to first num plus second num. So we are saying we are creating a variable called sum, and then we are saying this sum is going to be equal to first num plus second num. So we're adding these two numbers here and put into our variable called sum. Then we are able then to take this sum here and return a sum, right? Very simple. We want to print out, if we want to actually see this in action, what we do, we go ahead and say print. And then inside here, we can just go ahead and say the sum is, and then let's go append our add numbers. And of course, we pass in, let's say pass in 3, and then remember the second has to be labeled, so the second argument needs to be labeled. So say second num colon, and let's see 5, and you can see right away the sum is 8. So 3 and 5 is 8. Now what we wrote here, it works, but it's a little bit cluttered. So it's always a good idea. I like to put things in variables. So what we can do here, we can just say let final sum be equal to add num. So I'm going to call the method here. Well, it tells me right away that add numbers requires first num and second num. If you recall correctly, you've seen this before when we were coding our applications, where we would invoke certain functions and then this would happen. Code guessing here. All right, great. So now let's go ahead and pass in, let's say 4, and then for the second, let's pass in 5. And here, now this final sum here is holding the result which we are getting from our method here. Okay, so now we can use this final sum and copy this and just pass inside here, Ctrl V, and we're gonna get the same result. We could have left as it was, but this is visually more appealing because you can then understand what's exactly is happening here. The beauty of returning something is that as we return the sum here, we can take that sum and put it in a different variable and then use that variable and then display. And if we wanted to, okay, this is the beauty. I'm just showing different things we can do. Since we are returning a number, because we said it's an integer, we can even add here. We can say if we want to add 10, for instance, let's look what's going to happen. 19, right? Because now we're saying the add numbers, which returns 9 in this case here. Once it returns 9, we want to add 10 to it. And guess what? Final number is saying 19 because now 4 plus 5 is 9 plus 10 is 19. And you can keep adding 6 to 7, for instance, and so forth. That's great. And obviously, you can go ahead and put many other arguments here, as many as you need. But it's always a good idea to put minimal number of arguments because you don't want to end up having 30 arguments and it just gets a little bit verbose and a little bit confusing. But you know, there are big times you probably need 4, 5, or 6. That's fine. As a little challenge for you, go ahead and create 2 functions. One will subtract numbers, 2 numbers, just like we did here. The second one would multiply 2 numbers. All right, I hope you manage it. So essentially, you will do the same thing, all right? So you would go ahead and create something like, for instance, you can say func, and you can say subtract numbers, right? And go ahead and you can go ahead even say first num, int, second num, type int, and make sure you are returning the integer, of course. And here, let's go ahead, I'm going to copy this and pass there in. And instead of sum, I can say result, first number minus second number, and return result. You can go ahead here and say let final res for result be equal to subtract first number. I'm going to say 8, second number I'm going to say 6, right? And then I'm going to say print. I'm going to go ahead and say result is, and I'm going to pass in the final res. And there it is, result is 2 because 8 minus 6 is indeed 2. All right, so very simple, nothing too complicated, and I'm sure you were able to also do the same with divide and multiply. Wonderful, great. So let me go ahead and put this at the bottom here so that we can go ahead and proceed. I'm gonna go ahead and comment this out so we don't have it distracting us. The other thing I would like to point out here, you may look at here and say, well, because here we have first num as int and second number as int, that therefore we can only return an int. That's not necessarily true. I will show you why that's not true. Let's create this very simple function. Say func, we're gonna call this char numbers. In this function here, we are going to pass in a string. So we're gonna say my string of type string, and we want to return an int. So what we're going to do, we're going to pass in a string, and then we're going to return how many characters are in our strings, right? So what we can do now here, we can go ahead and say return. For now, let's say return 0, so we don't have that error. And now we can say here, char count be equal. Now we're going to go ahead and get this my string here we're passing in. Say my string dot characters, and then we say dot count. So now this char count here has the count or the number of characters in our string that we're passing in here. So now we can go ahead and just return a char count, right? So as you can see, our argument here is actually a string, but it's returning an integer. So now we can go ahead and say print. Let's see, we can go ahead and let's say char numbers. Let's pass in a string here. Let's say hello. Look what's going to happen. 5. Because hello has 5 characters, right? So 1 character, H-E-L-L-O. So 5 characters. You can say here jobs, it's good, 4. Life, 4 as well. Light, as you can see here, should be 5. Okay, so this was, I just wanted to point out that, you know, you could have inferred from our previous example here that since we have integers all across in our arguments, then of course it has to return an integer. That's true, but that doesn't necessarily mean every time we have an integer here or any other type, that doesn't mean it has to match with what we're returning. In most cases, probably yes, but as you can see here, we are returning an int even though we are indeed passing in arguments here as a string. Okay, that's great. All right, so I'll see you in the next video. Previously talked about the int return type. Now we're going to go ahead and talk about the string return type. Okay, as you can see here, I went ahead and created a new project called return string. So I would encourage you to do the same. And remember, this is actually a playground project, not an iOS project. Okay, so go ahead and create your own project. How do we then create a function that returns a string? Well, simply we go ahead and say func, because that's our keyword. Let's call this function here show color. Okay, and we want to pass 2 arguments. So the first one is going to be color name of type string, and the next is going to be color number of type int, as an example. And of course, we want to be returning a string. And right away, again, you will have an error here pretty soon, because if you click, it says you need to return something, because we said here we want to return a string and we need to actually return something. For now, let's go ahead and say return empty string here so that we can get rid of this error. Okay, at the top here, let's go ahead and create a little bit of logic. That way we can spice it up a little bit. Okay, let's say if we want to say if color number, so color num, which we are passing here, is equal to 4, we want then to be able to return, say return a string that says at first we're going to append our color name that we've passed. Say color name, we can go is not related to the number you passed. I'm going to go ahead and else. We can go ahead and say, so if that's not true, this first statement here, we want to say, let's go ahead and copy what we have here and paste here. Put a little bit of space so it's all pleasant and nice to see. In this case, color is indeed related to the number you passed. Let's see, passed in, maybe passed in. Okay, so now else if color name, if a color number is not equal to 4, we want just to return this statement here. Okay, so now we can get rid of this. Now we need to call this function here in order for us to see the logic that we've written here, right? Okay, so if you go and say show color, and of course right away we have these options here, so color name and color int. Let's go ahead and pass in blue, right? And tab. Once you hit tab, You notice the cursor, it's already here so that we're ready to enter the color number here. Let's say 3, for instance. All right. Once we call it, says blue is indeed related to the number you passed in, because according to our logic here, this is true, because 3 is not equal to 4. Therefore, the else statement will run, which is exactly what we are getting here on the right. Perfect. So blue is indeed related to the number you passed in. If we go ahead and say 4, so 4, blue is not related to the number you passed in. Now you know how to create a function that returns a string. All right, so I'll see you in the next video. These that group together statements that perform operations. Now, the difference here is that classes are templates that describe behaviors and states that the objects will have. So classes are used to create objects which in many languages, especially in Swift, they are simply a representation of a real-world object. So classes are the blueprint of objects, and these entities are the building blocks of objects and object-oriented programming. For example, in the real world, we have, for instance, a ball. This could be a basketball, a soccer ball, or even a football, right? American football, of course. All right. So now this ball here has properties. This ball could have color red, size, and so forth. Those are properties of this ball. Also, this ball has behaviors. So this ball can bounce, can inflate, deflate, and do a lot of things. So as you can see here, we can actually represent a real ball in terms of code by creating classes, which then we can instantiate, we can create objects out of it. One important thing I need you to understand when you think of classes and object is that think of a class as a cookie cutter. You use a cookie cutter to cut shapes of cookies, which then you can create a lot of different cookies, all of them from one cookie cutter. Now, the object in this case would be then the actual cookie, because you've used the cookie cutter as this blueprint to create shapes of different cookies. Let's go ahead then and take a look at how to create classes, which in return create objects. All right, let's take a look. So I went ahead and created a classes project, a playground project. So go ahead and do that. How do we create classes in Swift? We go ahead and say class, that's the keyword, and Swift is kind enough to give us a hint as to what we need to create a class. So as you can see, there's class, and then we have to add a name. So the name, let's call this ball. All right. So here we go. We have our class. We name it ball, and notice we don't have the parentheses here after ball. Instead, we actually have braces. Now, in our little presentation, we talk about class as this entity that holds properties, and it also holds behaviors. If you think of a real-world ball, a ball will have color, size, and many other properties. But for now, let's just use those two properties. So we're going to go ahead and say var color. We want it to be of type string and say enter. And we notice we're going to have an issue right away. If you click here to this red here, it says fix. Class ball has no initializers. So this is a good time. Let's go ahead and fix it. Just go say enter. This is a good time to talk about initializers. Later, we will actually create initializers for our classes. So it turns out in Swift, every variable you create, it has to be initialized. So as you can see, we can't just say var color of type string and nothing there. We have to actually say explicitly that is empty, or if it's an integer, we put 0 or nil or something. So we have to initialize them. If you try to do otherwise, you will get an error, which is good, and then Swift always reminds us. So that's our first property. Our second, we're going to say var size, and it's going to be of type int. Enter. Let's initialize it to 0. So these two here are our properties of our ball class. So behaviors is anything our object does. So a ball can deflate, can inflate, and also a ball can bounce. So those are behaviors of what a ball does. Now, if we talk about behaviors and we talk about what this item does, you can right away infer that we could also say the way we represent behavior in our code here would be via function. So we can create a function here, say func. We've done this, and we're gonna say bounce. And of course, it's a function, we have to close there. All right? And let's go ahead and make it return a string. And here, what we can do, we can go ahead and say return a string that say I bounce. Perfect. Okay, so now remember here, this class here, ball, it's just a cookie cutter. It's a template. It's a blueprint. It's not necessarily an object we can actually use and do things, do useful things with it. So it's an entity that on its own makes sense. A ball has, properties, so in this case, color and size, and has behavior, it bounces. Now, how do we then create an instance, an actual object off of this ball here? Simply here, instance of class var, because we have to assign a variable. I'm going to call it my ball is equal, then I just say ball and close parentheses. What's happening here? I'm instantiating my ball of type ball. So essentially, I'm just creating a ball in memory using this blueprint here. Okay, now that I have my ball here, an actual object instantiated, what I can do now, I can access properties and the behaviors. Okay, I could go ahead and say my ball dot size is equal to, I can give it a size, I know it's an integer, I can say 12. All right, I can go ahead and say my ball again, and you notice the moment I say my ball, the system already knows that you're talking about this my ball here, which is of type ball, is the actual object from ball class. Okay, so enter. Then let's access the color. Let's give it blue. Let's print something. Let's say print and say here's my ball. And then let's pass the values. Let's say my ball dot size and my ball dot color. Notice what happens. Here's my ball, 12 and blue. Because what we did, we set my ball size, my ball property size to be 12 and the color to be blue. All right. If we then wanted to access our bounce behavior here, we call this, by the way, an instance method because it is included inside of our class here. So in order to access that, we can go ahead and say print and let's append and say my ball dot bounce. Close that and I bounce. So it's returning I bounce behavior. Okay, or rather let's say bouncing because that's correct. All right, like that. And I am bouncing. Now the beauty of this, because we talked about cookie cutter, we talked about creating a lot of different cookies with just one cookie cutter, in this case our class here, ball, I can create as many balls as I want. I could go ahead here, if I want, I can say var, let's call this basket ball, and create an instance of it. So I say ball, right? Now I have a basketball, which has all of these properties and behavior. And then I can go ahead and start setting up properties for basketball only. Say basketball dot color is equal, say red. Okay. I can also say basketball dot size. Let's say 23. Of course, these sizes are not accurate at all. And I can go ahead and print basketball, and I can say basketball dot color, okay, and basketball dot size, and you can see basketball red and 23. It's showing here to the right. Create here, say soccer ball is equal ball, right, and do the same. Say soccer size and say 10. Okay, soccer ball dot color, give it a white, and let me copy this and do the same here. Print copy this and just there. And you can see basketball white and 10. This is object-oriented programming because we created here our class, and then we can instantiate as many times as we need to and create different instances of ball. And of course, in behaviors, we can put as many behaviors as we want, as well as on properties here. So this is just an example to show you how to create classes and how to use those classes to then create objects. And you notice right away this dot notation here. We've seen this before, where when we were creating our iOS projects, you notice that Xcode already brings a lot of classes and objects for us to use. Because you remember, for instance, we talked about the UI color. For instance, if you just type here UI color, as you can see, this is a class. You can see here, it's a class. So somebody had to create this class here, just like what we did here. There's no difference. And added instance variables or properties and added behaviors and so forth. Okay, you can see here UI collection view update item is a class and many others. I hope you start seeing the power of object-oriented programming here, because it allows us to have a lot more flexibility on creating objects and classes that create objects which we can use in our programs. And it makes our code much more readable, more efficient, and more usable. And extensible, so we can then extend things, use classes that somebody wrote, such as, UI color. That way we don't have to recreate the same class. We can just use the same class and get the job done. Okay, so, this concept here may be a little bit strange at first. I hope I was able to give you the basics of how to create a class and how to, from classes, how then to create objects, in which case we did here. Understanding the whole point of having to go through this process of creating classes and all of that. And of course, this will become more apparent as we go through this course, but now you have a solid introduction to object-oriented programming. And I would like you to go ahead and reread this code here, write yourself and create different classes, add more properties and more behaviors, so you can start seeing on your own how all of this stuff works. It's really important. All right. Okay. Well, I'll see you in the next video. So it's still on our classes project, playground project, that is. Previously, we talked about how to create a class and how to instantiate objects off of classes. As you see here, we have properties and we have behaviors. And then here we are creating an instance of the class ball, which means we're creating an object. We created another object, basketball of type ball, soccer ball of type ball. All of these share the same template, which is our ball class here. And of course, we went ahead and accessed using the dot notation properties of our class, added values to them, in this case size and color, and then we printed them out. So we saw the states of our objects as we instantiated them and added values. Now we need to talk about initializers. So when we want to talk about initializers with classes, we need to think about the states of our objects when they are created. In other words, when we instantiate an object, as we've done here in this line here, right? In the beginning, the object has nothing per se, right? Because if you look at this class here, the properties, color and size, so we kind of forced the initialization of these properties here, which is fine. But in a more robust way of creating classes, we need to find a way that we can internally, when the objects are indeed created, we want to make sure that those objects, they at least have certain default states. Okay? Think of it. So as we said previously, if you think back of what a class is being a template is not necessarily the actual thing. Meaning, if I say, for instance, a blueprint of a house, it's not necessarily a house, right? In order to actually have a house, you have to actually build the house using those blueprints. So in this case, this ball here, it's just an abstract representation of what a real ball would do or would look like. As such, as we instantiate, as we create objects, as you see here at the bottom, so basketball, soccer, my ball, as we create those objects, we want to make sure that they have a certain state, they have certain properties, okay? So Swift actually allows us to initialize our objects in a way that anytime object is instantiated, it already comes with predefined, if you will, or default values that will make them real world objects. Meaning, a ball without a color or a size wouldn't make any sense in the real world, right? Because if you think of a ball, it has to have at least a size and usually has to have a color. That's what makes a real ball, okay? So the way we initialize an object, or at least the template, so that when the object is created, there's some initial values. We just go ahead and say init. As you can see, there it is, our keyword, enter, and then we have our braces there. So inside here, that's when we can initialize values, in this case properties, or anything else we want, but in this case it's just going to be properties of this class here. So while we're here, let's go ahead and comment all of this out here we've been working on. Command exclamation point key, okay, and give it a lot of space here. So now to initialize that, what we can do, as you can see at the top in the properties here, we went ahead and say color, it's type of string, gave it an empty string, okay? But now let's get rid of this. Let's go ahead and get rid of that. We're gonna have a problem if you click here, return from initializer without initializing all stored properties. So we have a problem again because it's saying, well, these properties are not initialized, so that's a problem. Inside here, what we can do, we can then initialize our properties here. So say color is equal to, say blue, and go ahead and say size. Now, notice what's going to happen. If I go to my ball here and say dot notation and hit size, look, we have 12. Because we're saying here in our initializer method here, we're saying that size field or property, okay, we want it to be 12 when this object is created. And we want also the color to be blue. So if we say color here, we should see blue. So now we know this object here, internally, we know it is initialized. And the other thing to notice here is that our init method here, well, for once, it's a function, it's a method, it's an instance method, right? Because it's inside of a class, we call them instance methods. Same thing as function, but just terminology, okay? We can actually pass in arguments as well. If we want to pass arguments here, which means when we instantiate the object outside, okay, we'll have to pass values inside of our class here. Meaning, let's go ahead and say here, color of type string. I'm going to say size, also size of type int. Now you notice right away we have a problem here. If you click on this red button here, cannot invoke initializer for type ball with no arguments. It's saying, well, you told me to create an instance of this object, this class here, to create an object, but this class here, the blueprint, has an initializer that requires to pass arguments, okay? It is a contract. So now we need to go ahead and say color and give it, say, green, and size, let's give it 45. Okay, there we go. But now notice we have a problem here. Let's go inside of our init, we have color. If you click in here, it says mark parameter with var to make it mutable. So it's saying if we want this to work, we need to make this var, this parameter here, var. That way we are able to do this. Now, here's what's happening here. You notice we have color and we have size. And you notice here as our properties, we have color and we have size. One thing we need to pay close attention here is that what's happening, this color here, variable here that we are passing in blue, is not this color outside, which is the property, which is exactly what we need. The reason why this color here is not exactly, the one outside is because these are in different scopes. The thing we need to do here, we need to use a different keyword called self.color. Now, if you click, just notice how things change here. If you click on the color, look, this is kind of highlighted here as well. Because now what's happening, we're saying self. This self keyword here refers to our class ball. Would be the same as saying ball dot color. Okay, but we can't do that. We have to go ahead and say self because that's not an object yet. So the self here, we're referring self as me, in this case, this whole class here, dot color. So we are accessing this class's color property. And then what we can do, because we are accessing our color property, then we can just pass what we are passing in our init method here. Let's say color. And we can do the same with our size. So self.size, instead of just hard coding the 12, we can just pass in the size. Okay, and now this class, it's becoming more and more dynamic. So now here, if you go to create instance of the class, we can say var my ball is equal ball, and then we pass in these values as arguments. Now this class here, if we get rid of these values that we passed, we're going to have an error because again it's saying, well, since I have an initializer, the initializer has parameters that we have to pass. Again, that's a contract and you're not passing anything, therefore I'm not going to compile. Something is wrong. Okay, so let's put that back. So there we go. So here we have initialized our class. And there it is. And again, I would like to let you know that I know this may sound really difficult. Like, oh my goodness, it's so difficult. Some of you may feel as if there's no need to learn all of this because it's just, I mean, when are we going to use it and why? At a later time, we'll start using classes. But the main reason why you need to understand classes and object-oriented programming, because Swift is highly object-oriented programming, as we have spoke earlier. If you look at all of, for instance, the UI color or UI image for that matter, that's a class, right? You can see there's a class, there's methods, and there's so forth. So everything was built using object-oriented programming thought process, which allows us to leverage our applications in ways that are more sustainable, more flexible, and more efficient. All right, so good. So go ahead and study a little bit this ball class here and create your own classes. And the way you think of a class, if you want to figure out, for instance, what makes a class in the real world, or abstractly speaking, anything that is a noun can be a class. A ball, as we saw here, is a noun, so you can represent that as a class, right? For instance, a dog is a noun. You can represent that as a class. A car is a noun. That could also be represented as a class. So anything that is a noun can very well be represented as a class. Perfect. Great. So I'll see you in the next video. Oriented programming, which is very important, called inheritance. So the idea of inheritance, the word itself, inheritance, means getting something from our parents, genetically speaking. Right? So you and I have parents, so most of our traits come from our parents. The same way we can represent this inheritance, genetically speaking, right? Getting traits from our parents, we can also do the same with objects and classes. So in this example here, we have, for instance, a class called ball, and then at the bottom we have baseball. If you look at the arrow pointing up, it means that the baseball here inherits from ball. So the ball, in this case, will be the parent class or the base class, okay? And then the subclass in this case will be the baseball. What this also means is that the baseball in this case gets all of the properties of a ball, gets all of the methods or behaviors of the ball. All right, so this is what we're going to be studying, looking at in this video here. All right, let's get into code and put this together. All right, so here we are back in our classes project here. Remember, this is a playground project. And so now we're going to talk about inheritance. So previously we were able to create a class. As you can see here, we created a ball class, has some properties, in this case, color and size. And we have our init method here, which takes in color and size. And then we initialize those values. We have behaviors, in this case, just one behavior, which is okay. And once we have all set up, we then create an instance of that class. In this case of our ball class, we call my ball, and we of course have to pass in our color and size because those are the values that we initially want our objects to have when they are instantiated. Okay, as you can see here, when we said print my ball dot notation here, so we're accessing one of the properties. Okay, in this case color, it gives us green. Why? Because in our ball instantiation here, as we create this my ball instance of the ball object, then we passed in green. Okay, So now let's talk about inheritance. So in order for us to inherit from, let's say, the ball class here, which means we'll create another class which will take all of these properties and behaviors, also the initialization, the init method here, we do the following. So what we do, we of course create a class. So we say class. In this case, we're going to call baseball. Notice that all classes naming start with an uppercase. Okay, and usually they are nouns, which means they only have one word. So baseball. Okay, car, vehicle. Now we're going to go ahead and put the colon, and then we're going to put the name of the class we want to inherit from. In this case, we want to inherit from the ball class. So here, what's happening again, we're saying ball class, which we're creating, inherits this colon here from ball. Of course, let's go ahead and have braces there, so we have a body there. And if you remember correctly, this notation here, we've seen this before. If you go back up here, you notice whenever we are creating variables here, we said var, color, and then we have the same notation, and we have string. Well, guess what? Internally, Swift is doing the same thing what we're doing here. Very implicitly, what we're saying here, we're saying color is of type string, meaning color inherits from string. You see? So this actually gives you another reason why, if you were to ask yourself, well, why is Paulo putting me through this and teaching me about all of these classes and objects? I don't care about that. I just want to build apps. Well, that's very true, and I understand that, but you can see that everything that we've been doing, it's all object-oriented, even when we create our own variables. Okay, good. So back to our baseball here, which inherits from our ball, which again means it gets all of the properties and behaviors as well as the init method here. Okay, it's empty for now. So what we can do, let's go ahead and create an instance of this baseball class. Okay, so let's go ahead and say var my baseball is equal to baseball. Right away, we have an error here. So let's go ahead and click on this red here. It says missing argument for parameter color in call. Well, but you will say, well, what's going on? I didn't ask to put any parameter in our baseball class. Well, the reason why it's missing, it's saying it's giving this error is because my baseball here inherits from ball, which has all of these properties and behaviors and has this init method here inside. Since we are inheriting from the parent class, the ball, that also means we have to conform to what the parent class needs us to do. In this case, it needs us to actually pass on parameters which can be used to initialize our object. So in this case, we have to say color. As you can see, the moment you say color, it gives you all of the arguments that needs to be passed in order for this to work. So you say color and size. So type in string there. What color? Let's say, just say new color for now so we can say the difference. And tab, it takes you straight to the size. Let's say 123. Okay. And there we go. Now my baseball object here is instantiated. And we pass a new color, size. If we change here, say my baseball, there it is, say enter, color, is going to say new color because that's what we passed in here. And you can see this is the power of inheritance. We just said baseball inherits from ball, and it took everything that ball provides and made it its own. All right. Now you may say, well, what is the point then of inheriting from our parents, in this case, our parent class or our base class, the ball, if we could have just used ball, right? Well, it turns out there are times when you want to inherit from your parents, but as you know, we are not necessarily the copy of our parents. Sure, we have, same features, maybe the same nose, same type of hair, and so forth, but we have other things of our own. For instance, we have our own behaviors, right? We have our own level of intelligence and so forth. So there's a lot of attributes or properties and behaviors that are not of our parents. So we need to have our own. So that's the beauty here. So when we inherit from our parents, we're saying, well, we need all of those basic traits of our parents, in this case of our base class, so that we know we are indeed a copy of our parents, but we also want to be able to have our own traits or properties or methods or behaviors. So in the next video, we'll talk about overriding certain behaviors and properties of our parent classes so that although this new object here, the subclass, has all the traits of the parent, they can also have their own traits in addition to what they have inherited from their parents. All right, so great. So I'll see you then in the next video. The subclasses, their own characteristics in addition to what they've received from their parents. So in this case, we could argue that, well, baseballs have different behavior of bouncing. So baseball may bounce differently from any other kind of ball. We could go ahead and say override behavior. To override a behavior, we simply say override, that's the keyword, and we say func bounce. You notice I didn't have to type a lot of things here. Most of it was automatically written for me. The reason being is because, as you can see here, we said override func bounce. Notice the bounce has to be the same as the bounce from our base class, our parent class, because that's what we're doing. We're overriding. We're saying we still want to use that bounce. Instead of using my parent's bounce behavior, I want to use my own bounce behavior, which characterized me as a baseball object, not just a ball. We can just go ahead and say return. I bounce like a baseball. And now here at the bottom, my baseball instantiated is here. We can go ahead and access that method. The moment you say dot notation, so you can access all of this, there's the bounce, and look what's going to happen. I bounce like a baseball. It's not showing the bouncing from our ball here. Why? Because we said override that method. So you can start seeing the power of object-oriented programming, because now not only we have a baseball object that has its own behavior, it is indeed overriding the parent's behavior. Obviously, we can go ahead and add other behaviors here that are particularly for our baseball if we wanted to. In this case, we don't need to override anything. We can just go ahead and say func show color, for instance, right? And we can pass in a color string, and we make sure that it returns a string. And here we can say return color. There we go. So you can see now we have this show color func, which is not being overridden from anywhere because we don't have any other behavior in our ball class here, which is the parent, right? So we are creating this method, this function here inside of our baseball. So this is just for our baseball. You can see if we go print here my baseball and say, for instance, show color, there it is. We of course have to pass in a string and say blue. Okay, let's get rid of all of this extra residual. And you can see my baseball.show color is blue because we've passed in the blue there. We are also able to add properties. So new properties. Let's say if we want to add a name property, we can go ahead and say private, right? Var name, and we say string, okay? And then go say private, var is round, okay? Let's make this a boolean, so true or false. So now we've added these two properties here. So name, which is a string, is round, which is a boolean. And we say private because we want this to just be accessed inside of our file here. Okay, now we have a problem here. If you click on this red warning here, says class baseball has no initializers. We need to initialize our new property. And we could have gone ahead and say just like this, put an empty string there and put here say false. That would solve the problem. But since we have learned how to actually use an init method inside of our classes, let's just use that then. Instead of hard coding as we did here, let's get rid of this and this one here as well. We are going to get an error again. We say init, open parenthesis, and let's pass in name of type string and is round of type boolean. It's a method, so we have our braces there. Now inside here, this is where we're going to be initializing our baseball class, which inherits from our ball. Okay, now notice something very interesting here. You see I say name and is round as the parameters that I'm passing in, which coincidentally are the same name, have the same name as our private properties. Now this is not required, but I always do this way because it makes it much easier for me to know what I'm setting up, because I would know its name and is round. And also notice when you use this way of doing things, having the same names as the properties in our parameters, this is when we use this self in order to set our properties inside of our init, because that's the whole reason why we have initialization, because we want to set things up, right, for our object. We say self dot, and then we are taking the property of our object here, baseball in this case. First one is going to be name, this one here, and you can see right away there's a little dash thing that happens at the bottom here, which signifies we are indeed talking about this property here. So we're saying we want this property name to be equal to receive what we are passing in our initialization. So when we pass here, say color, new color, that's exactly what's happening. We are saying then taking this color and pass inside of our property. Of course, in this case, it's a different property, but you get the idea. And we do the same. Self dot is round is going to be equal to whatever we pass in our parameter. So we're taking this is round, it's passed in, and we are setting our is round property to be whatever we pass in. Before we do anything, we're going to call super. So super is our parent class, which means we are calling now our ball here. We want to call its init, which is this one here. So we say super dot init. There it is. Obviously, we have to pass in a few things here. So we can go ahead and just pass in, say, green, and for size, let's say 12. Now, right away, we have an issue here in our instantiation where we instantiate our baseball object. If you click, it says cannot invoke initializer for type baseball with an argument list of type color. The reason why it's happening because we already called here super init color and we passed in everything. What we need to do now is actually call our own init here, because this init is already done, because this is from super, which is the parent class. All right. So what's happening here, this my baseball is saying, well, I don't know what you're talking about, this color thing, because I have no idea what that is as far as I'm concerned, because I'm only concerned on my init unless I am called as super. So that's why we're having this error here. So we need to actually go ahead and use name as and is round as our parameters here to initialize it, because that's exactly what we did here, right? In our baseball class, which inherits ball. We're gonna go and say open parentheses, and right when you open parentheses, it gives you the correct parameters or arguments you need to pass. In this case, name, so say tab, let's say baseball, and is round, let's say true. Okay, because again, it has to be a Boolean, so true or false. There we go. Now we have my baseball object instantiated correctly. And now to make sure this works, let's get rid of this. Let's go ahead and say my baseball dot size. Let's see what size it's going to give us. It's giving us 12. Why? Because if you look here in our init, we initialize size to be 12 because we are inheriting from our main ball class. And I can do the same. I can say, let's put comma and say my baseball again dot, for instance, name. Let's guess what's going to happen. It says baseball because we said our name of this is going to be baseball, right? And if we go ahead and say my baseball dot is round to see if it's round, it's going to say true because we said is round is true. Now let's check something very interesting here. Let's go say print my baseball dot bounce. What's going to happen? I bounce like a baseball. Why? Because we already overrode this bounce method here because it's not calling the bouncing. All right, it's great. So you've learned how to override functions, method, in classes, and you've also learned how to even add other behaviors in the subclasses, and also learn how to create new properties in the subclasses, but still holding all of the properties and behaviors from our parent classes. So go ahead and play around with this concept here. And I understand it may be a little bit confusing at first, but trust me, the more we look at this, the more we learn about this, the easier it becomes. So just go ahead and write your own classes. So in the next video, we'll continue talking about inheritance. And one more thing that I would like to share with you before we proceed into other things. All right, so I'll see you next. Class, which again is the child class or its subclass of ball. Okay, now if you look here, we have var name as our property and is round. These are our properties. And of course, we can go ahead and access those properties as we did here, and we can set them up as well, right? We could say, for instance, here, we can say my baseball dot color is equal to, we can say blue, for instance. We can go ahead here and say my baseball dot color, and it's gonna give us blue because that's what we've set. So going back to the idea of a class, we said a class needs to be a self-contained entity which has all of the properties and methods or functions or behaviors in this case. But all of this has to be contained. Think of it as a little box, black box of a car that has all of these things that work together, but you and I don't even have to know what those things are because all we care about is how to drive a car. So if you think of it as it's just an entity that has everything that needs to be done in order for something to happen. So to make our classes really work as an entity, we need a way in which we can either set things internally, all right, in our class, and retrieve things as well internally and process all those things internally. That way, the idea of having everything confined in one entity is truly happening. A good example would be with our show color here. Okay, this our show color is a function that we can pass in a string as a color and then returns that color. So what we could also do here, let's change this to, for instance, show name, so that we can use what we already have here. Let's create another one at the bottom here, func roundness, something like that. Return a string. Okay, and of course let's return just empty for now so we don't get an error. Okay, that's good. So now we have show name and show randomness. So the show name is supposed to show the name of our ball. Okay, now instead of passing anything here, let's get rid of these parameters here. What we can do now, we can actually say show name return color. Now inside here in our class, our baseball class, we don't have a property called color, but yet we are okay with this color here. If you click on that, you will notice that guess which color is being referred to. It's referring to the color of our parent class. If I say my baseball.color is still gonna say blue as we want it to do. Let's get rid of this and this as well. So for here, let me go ahead and say name. And you notice right away here, the name here has dashes at the bottom here. When you click at it, you can see which one it refers to. So we're talking about the name we are initializing here, which incidentally is our property. So now this show name here returns whatever name we have added to our baseball. Okay, so if we go here and say name is baseball as we had here when we instantiated our main baseball, guess what? Let's change this to the baseball just to see the difference here. You can see right away to the right here we have the baseball, which is what we set it to be here. But now since we have actually a function, a method which returns that name, we can now use it as opposed to going and fetch the property, right? So now let's get rid of all of this. What we can do, we can say my baseball dot, you can see we can go ahead and say show name, there's a method there, and it's going to go ahead and say the baseball. So now we're organizing our class so that it actually works as a true entity, that black box in your car that does all of those things internally to make your car work. Okay, so now if we can do the same with show randomness, we can go ahead here and just return. In this case here, it's not going to be a string. We can just, because we know that round is actually a boolean, let's just go ahead and say bool. So now it's going to return is round, right? And there it is. So now we can do the same here. Say comma, say my baseball, that is round method. We need to go show roundness in this case. And you will see it's gonna say true. All right, if we want to change to false here, in this case our roundness is gonna be false. Let's go back to true here. We can do the same thing here. We can go ahead and create another function method, say func. Let's say we want to show color. All right, so this will return a string. Let's put a return something here so that we don't get an error. Okay, so show color is going to return a string which has the color that we set up to be. But notice something here. Inside of our class baseball, we don't have a property called color. But remember, we are inheriting from our ball class, which indeed has color property. And it's all set up there. Which means since we are inheriting from the parent class, we can go ahead and say, type here, color. What's going to happen? If you click on the color and you go up, you see there's a dash here, which indicates there's another instance of that. Scroll up, look at that. It knows right away that you are talking about the super color, the parent color. See? But the best way, usually the way I like to do this is to, that way I'm not confused, is I usually go say self.color. That's the same thing, which what are we saying here? I'm referring to the parent color or the parent class or the base class color. In this case is our ball. So either way works, but I like to use self, that way I know what I'm referring to when I read the code. So now if I go ahead and say show color, right? Let's see what's going to show. Let's go ahead and comment that out. And let's say my baseball dot show color. There it is. What color? It says green. Why? Let's go back here, because in our init, on our baseball here, inheritance, in our init, when we call the super, the parent, we gave it a color of green. Okay? So this way, now our class here, our baseball class, is its own entity. It has its own properties, although it still has the parent's property as we've spoken about earlier. But it knows when to communicate with the parent, when to actually show the parent's characteristics, and when to show its own through overriding functions, right? Overriding behaviors and so forth. So now you have a very solid idea of what classes are and what classes do and how we create objects in Swift 2. Again, don't worry too much if this makes no sense, okay? If it's kind of a little bit complicated, because, you know, it is complicated, but it's not at the same time, okay? What I mean by that is that it may seem complicated now, but as we progress in our course, code, as we build more applications, you'll see object-oriented programming coming over and over again. As we spoke earlier, the entire Swift 2, the entire Swift language is built upon objects. It's built upon classes. Again, go ahead and play around with this concept here. And if you have any questions at all, please don't hesitate to ask, because it's really important that you understand these concepts here. Okay, and keep at it. If you don't get it first time, go back and watch the videos and ask questions and keep at it. All right, congratulations for making it this far, and I will see you in the next video.